In this 6-hour long video, you will become a pro PySpark developer even if you do not have any prior experience. We will learn all the functions available in PySpark. We will work with different file formats. Plus, you will learn about many complex real-time scenarios which are asked in the interviews. Yes, everything is available in this 6-hour long video. Wow, that sounds amazing. As we all know that Spark has become one of the most important technology right now in the world of data engineering, and demand is growing rapidly. But wait, who's this guy? Well, I am an Azure data engineer and has obtained some in-demand certifications such as Microsoft Certified Azure Data Engineer, Databricks Certified Spark Developer Associate, and many more. When I was learning Spark, I had to refer so many different resources such as different Udemy courses, so many YouTube playlists, and none other than this book. By the way, this book is a gem. I decided to conclude all these resources and create a one-stop solution for all the data lovers who want to become a pro PySpark developer from scratch. Plus, you do not need to pay for any of the resource. Everything is available for free. Just hit the subscribe button because this will motivate me a lot to create lots of content in future, and let's get started. So welcome. This is the PySpark Masterclass where you will be learning most in-demand technology right now, which is Spark, and we will be covering Python API within Spark, which is also known as PySpark. So welcome again. In this particular video, we will be covering PySpark from scratch. So if you have some experience, then it is good. If you do not have any experience, then also it is good because we will be covering each and everything from scratch. So let's quickly look at the agenda today. So in this particular masterclass, we will be covering all of these things and obviously our OG PySpark coding. And before beginning with PySpark coding, there are some terms, definitions, prerequisites to actually start working with PySpark. So first of all, we will be covering what is Spark, a quick definition. Then we have Spark architecture. This is the most important topic for today because you can expect at least 2 to 3 interview questions revolving around this sole topic. So we will be covering this as well. Then we have Spark benefits, where we can talk about why we use Spark over Hadoop. Then we have lazy evaluation. This is yet another important topic because you can expect at least one question, I'm sure. Then we have job, stages, and tasks, a quick overview, the architecture of this. Then we have Databricks free account. So we need a platform to run our Spark code. It can be your Jupyter notebook, it can be your on-prem, it can be cloud. So for today's masterclass, we will be using Databricks. If you have account of Databricks within Azure, GCP, AWS, it's good. If you do not have, we will create one community account in which you can perform all the operations for free of cost. So I will tell you how you can create a free Databricks account because I use Azure Databricks, so just ignore that. Then we have Spark language options. We can use multiple languages within Spark, so we can discuss what are the options available. Let's get started. First of all, we will be covering what is Spark. So Spark is basically a distributed computing engine which distributes our data to process it. This is the simplest definition for you. So let's say we have a data of 1 GB, right? And we want to process this data. So we have options. Either we can use this particular machine that is on the left hand side, which is just one machine. We can increase the resources of this particular machine to process the data efficiently. Then we have second option. Second option is this one, which is using multiple machines and we can connect them together and we call it as a cluster. So let's suppose you are working in your computer lab of your college, of your school, and you can connect all those computers and can tell them just act as a one machine. So you can imagine the power. Second thing is we can scale it to the infinite numbers. There is no saturation point, there is no limit. Whereas in case of this particular machine, obviously there is a limit. We can increase the RAM, ROM, storage, everything to a certain limit. So this is a good choice, which is the second one. This one, we choose U. So that is the definition of Spark. And Spark basically works on this particular architecture where it distributes the data among the machines. This is the simplest definition, and this is the best definition to grasp the concept. Then the most important topic, which is Spark architecture. I know lots of people have made it very complicated, but let me tell you, let me explain you this concept. Let's get started. Okay. So first of all, as we have just talked about that we work in the cluster of computers. So we have, let's say, 10 computers, and we are calling it as our cluster of 10 machines. We have one cluster manager. As the name suggests, it manages the resources. It manages the cluster. So what it does, first of all, it will create a driver node. Node means computer. So it is replaceable. You can either use computer, you can either use node. We use node in Spark language, so you can expect node with computer. First of all, it will create a driver node on our cluster. Okay, our driver node is ready. Okay, just forget about these part for now. Our driver node is ready. So whenever, let's say, I submitted the code, don't mind my drawing. Let's say I submitted the code, so it will go to the driver node. It will assess that code, it will break that code in the form of transformations, stages, jobs, tasks, and it will hand over all that information to our cluster manager, this one. Now our driver program requests cluster manager to create two worker nodes. This is just a hypothetical situation where we need two worker nodes. It can request many. So it will ask cluster manager to create two worker nodes. One is this one is this one. Then all the breakdown information that driver program provided to cluster manager will go to these workers, and these two workers will actually execute those transformations. So just to give you a brief again, just to revise the whole scenario that we have just discussed, driver program will orchestrate the tasks. It will break down the code into smaller tasks. It will send that information to our cluster manager. Cluster manager will create the worker nodes based on the information, and then those worker nodes will actually process our data. So that's why it is called master slave architecture, where this is the master driver program and these two are slaves, which actually carries out the transformation, processing of data, whatever you can say. So this is the whole concept behind Spark architecture. So you do not need to worry whenever you get the questions regarding this. I know this is pretty much complex. You can just rewatch this part if you want, but I think I have explained it in a decent manner so that you can just remember it. And this is really easy. Just rewatch this part and come back. Then we have some of the benefits. Why do we use Spark? Why? We already had Hadoop, right? Why you want to replace Hadoop? First reason, the in-memory computation. We can use memory that Spark has to process all the data. And this is one of the major reasons we have replaced Hadoop with Spark, because Hadoop was using disk memory and it was taking a lot of time to coming and back again and again. So we use Spark, which processes all the data in memory. Second is lazy evaluation. So we will be covering this part in the next slide in detail. So let me give you a quick overview. What is this? So whenever we perform the transformations, it will not immediately execute those transformations. It will create a logical plan. It will lazily evaluate all those transformations, and then it will execute all those transformations once we hit or trigger any action. Do not worry, I'm going to cover this part in the next slide. So just be with this particular slide for just a few more seconds. Then we have fault tolerant. In this particular feature, we get the ability to trace back all the transformations. So by this way, it provides us fault tolerance. Then obviously the partitioning, that is the fundamental behind Spark. It partitions our data, distributes that data to the cluster of machines. So this is the lazy evaluation. So do not feel overwhelmed by looking at this slide for now, because the concept is very, very simple. Let me explain you the whole concept. Let's suppose we have this data frame and we have performed transformations. Let's say transformation 1, transformation 2, transformation 3. This can be any transformation, like we are just selecting some columns, and in transformation 2 we are selecting some rows. In transformation 3 we are adding one column. So let's imagine you have performed these three transformations. So you will be expecting that transformation 1 will be executed, and then it will execute transformation 2, and then it will perform transformation 3. The answer is no. It will store all these informations, all these transformations into a logical plan, and it will optimize the plan. Maybe by performing transformation 2 first, it can give you the query in much faster time frame. So it will create the logical plan according to the optimization, and then once we hit this action, it is a kind of trigger. So once we trigger this action, it will execute this logical plan, and before that it will not perform any transformation. Yes, this is the concept of lazy evaluation. So it will store the information for all your transformations, and then it will create a logical plan, and then once we turn it on, okay, this is the action, okay, then it will perform all the transformations. And in Spark we have actions such as dot show, dot display, dot collect. Do not worry, we will be discussing each and everything when we will be performing Spark coding in the Spark notebooks. So this is the concept of lazy evaluation. Then we have a hierarchical structure. So as you can see at the top, we have our job. So job is basically the code that we submit in every cell. So within that job, we have different stages. Let's say one job have stage 1, 2, and 3. So by this way, it divides our job into stages. And similarly, each stage can have multiple tasks. So each stage will have task 1, task 2. In this scenario, we have just one task. So in maybe different scenarios, we have task 1, 2, task 1, 2, 3, task 1, 2, 3, 4. So this is the hierarchy that Spark follows to actually execute our jobs. Okay, here we are discussing finally about the PySpark. So before talking about PySpark, let's see what are the APIs that we have available within Spark. So APIs allows us to write our code in our native languages such as Python, Scala. Scala is good for those who know Java, SQL, and R. So in this particular masterclass, we will be looking at Python and little bit of SQL, because the thing is you can use the exact same coding as you write in SQL. So there's no use of rewriting each and every transformation. So we will be covering Python API most of the time. And when you blend Python with Spark, it becomes OG PySpark. And this is the most in-demand library within the Spark environment. No offense to Scala and R, but I personally love Python. So I will be discussing PySpark library. So this is our agenda for today. So now it's time to create your free Databricks account so that you can start working with PySpark. And for that, you simply need to go on Google and type Databricks Community Sign Up. Simply click on it and then you can see the links, and I would say you can click on any of the links. I will click on sign up, and then you simply need to select try Databricks, this one, and then here you need to give all the information that you have, and then simply click on continue. Once you click on continue, just make sure do not select any of these cloud platforms. You simply need to select this, get started with community edition, and then it will just ask you some questions. Okay, submit. Okay, verification is completed. Okay, so now it says check your email to start your trial. So you will get the email notification. You just need to open it and click on that particular email. So I'm going to check my email box. Ta-da! So here you are in your Databricks workspace. See, you are able to use Databricks in just few steps. So this is the homepage of our Databricks notebook, and as you can see here, lots of options available. Do not worry, I am here to guide you each and everything. First of all, let's have some vibe of this Databricks tool. So first of all, we have Workspace. Workspace is a kind of folder where we store our all the notebooks, and it looks really good when you have a dedicated location for all your notebooks. Let's click on it. Okay, so here we have 0 workspace because we have not created any. Let's quickly create one. So here you can see the create button. Simply click on it and type folder. So here we will see Databricks tutorial. Create. Now within this folder we can save all our notebooks. See, it is so simple. Then let's look at this particular tab, that is recents. Recents tab is just available to show all the notebooks or anything that you have just recently opened. Let's click on it. As expected, we haven't opened any notebook, so we can see 0 notebooks. Then we have search. We can search any resources within our Databricks. Then we have catalog tab. This is very important because we will be saving or uploading our data within this tab. Yes, this is very important. And for this particular tutorial, masterclass, whatever you can say, we will manually upload our data to the Databricks workspace. And yes, it allows us to upload the data for free of cost. So all the data files that we will be uploading, we will use this particular tab and we will upload the data manually, and we will access that data so that we can perform transformations on the top of it. Yes, I know you are very excited. Just hold your excitement for few more seconds, and then I will just take you to the journey of 0 to hero for PySpark. Then we have something called workflows, and within this workflows tab we orchestrate our notebooks. Let's say we have notebook 1, we have notebook 2, we have notebook 3. So build the connections and build the orchestration between those notebooks. We use this particular tab. Then we have compute. This is very important because this is the tab where we will create our compute, our cluster, so that we can perform our transformations efficiently. Plus, it is free of cost, so we do not need to worry about compute size, the version, anything. Then simply jump onto our data catalog because now it's time to upload some data. Do not worry at all because all the data files will be available in the link that I will put it in the description. You can download all those files and you can perform the uploading step as I am going to upload the data right now. So you can follow all those steps along with me. And once we have data loaded, then boom, we are going to use PySpark. Yes, let's quickly upload our data files. So now it's time to upload data to our Databricks workspace so that we can actually start working with PySpark. I have a CSV file called Big Sales. So let me quickly upload that file and let's get started. How you can upload that file? It's very simple. You simply need to click on Create Table, click on it, and then it will ask you to drop your files. So here, as you can see, that you can drop your files here. Simply click on it. So this is our CSV file that I have uploaded using my on disk, and I will provide you the link of this particular file and you can download it and you can also upload it here. Once you have uploaded it, you just need to take care of one small thing, which is this one. So this has given us the path where our CSV is stored, because when we read the data, we need to provide the URL, right? So just note this URL and it is very simple. Just backslash file store, then tables, then your CSV name. Simple and sorted. Now our data is uploaded. Now it's time to actually start coding. How we can create our first notebook? As you can see, we have created our first workspace. Simply go there. Then click on your folder, that is Databricks tutorial. Open it and then click on this create tab. Create, and this time you need to create your notebook. Simply select notebook. Welcome to your first Databricks notebook. Okay, so let me give you a quick overview. This is the cell where you will be writing all your coding. Then this is your notebook name. So first of all, just change the name, man. So let's say we give first and tutorial. So this is our notebook name and it will help us to navigate through notebooks if we have multiple notebooks. Then we have something called connect. This is the option that we need to select to actually create the cluster. As we just mentioned that Spark uses cluster of machines to process our data. So now we need to create that cluster of machines. Do not worry, we do not need to pay anything because this is a community edition. So simply click on connect. Then you will see this interface and we need to name our cluster. We can keep it as my cluster. Then here's the runtime, keep it same. Simply click on create, attach and run. So it will create a cluster and now you can see the status is changed from connect to starting. So now it will create the cluster and it will attach that cluster to this particular notebook. Remember, it can take few minutes to create the cluster, and once it is created, we're gonna start working with the data. And the very first step, you guessed it right, we will read the data. So now our PySpark coding is started. So our first PySpark transformation, PySpark code, anything you want to say, our very first code is regarding data reading. Because obviously if we want to perform anything, we need to load the data and we want to work with the real data sets. So we will be importing CSV file into our notebook and then we will perform transformations on the top of it, so that you can get some vibe of, you can say, working with real world scenarios, real world data sets. And yes, we will be using PySpark for that. So let's get started how we can efficiently read the data. Let me show you just like this. So here we are on our notebook. So let me tell you how to start working with PySpark. So first of all, as you can see, our cluster is ready. Our cluster name is my cluster. So name is popped up with this small cute green light. So that means we are ready to work with this cluster. First of all, we will create a heading because I like to keep my notebooks neat and clean. So first of all, how you can create the headings, right? First of all, we will learn the use of different command, different languages we can use within notebook. So simply click on this small button and there you will see Python, SQL, Scala and R. We mention all these languages in our slides. So now you can see within these cells you can switch the languages like this in just few seconds. And there's one more thing, that is markdown. Yes, this is the particular option we will be using to create headings, to create subheadings, to add comments within our notebooks. So this is a very handy option. Simply click on markdown and as you can see the magic command it has used, it is called magic command. It is %md. So if you do not want to use this particular box, you can directly type %md and it will create a magic command for you. So this is another handy option that you get. So first of all, let me increase some size of it, man. Now it looks good. So now you can see the %md sign here. Now if we type anything in this particular cell, Databricks will get to know, okay, this is a comment, this is a heading, this is not a code. So first of all, I will add 3 hashtags because I want to create the heading. If you want to create the heading, you just need to enter hashtags as a prefix and it is equivalent to h3 heading in HTML. So I will type, let's say, data reading. Now I want to run the cell. How we can run the cell? There is a simple method. Just click or just enter or just select shift plus enter. Simple. How did I do it? Let me tell you again. Okay, I'm on the cell. Simply click shift plus enter. Boom, it will run our cell. Yes, now we can see a heading and it really looks good when we add headings within our notebook so that we can get to know whenever we are returning to our notebooks after a few months and we can understand our code so easily because we will get the information. Okay, this particular cell is regarding data reading, this particular cell is regarding data transformation, this particular cell is regarding data transformation, and within that data transformation we are using a particular function. So you will get to know how handy and how useful it is. First of all, let's read our data. How we can read our data? It is very simple. Let me show you the code. First of all, you need to type spark.read. Spark.read is a data frame reader API within PySpark. So we write spark.read. Then we need to specify the format of the file. What is the format of our file? It is CSV. We will simply write CSV. Simple. Then we need to use a feature called option. Yes, option. In this particular feature, we will write that we also want to bring the schema. What is schema? Schema is basically the information that we have regarding our columns, like our column number 1 is of type int, our column number 2 is of type string. So all that information will be automatically brought by Spark. Yes, it is very powerful. And we have an option called infer schema. Infer schema, as the name suggests, it automatically infers the schema by having a look at some of the records and then it assumes the best fit regarding the data types. So you just need to mention infer schema and then put comma and then you need to make it true. Now Spark will go to our data, it will read that data, it will have a look at first few records and it will make the assumption for our data types. Yes, then we need to create another option because in this particular option we will say, hey Spark, please enable our header, because otherwise it will treat that header as our record, but we do not want that. We want our header to be true. So we can simply say header true. Simple. Now the only thing left is the URL. Yes, you are right. And we already know the URL of the file path. So simply write load. Oops. Simply write load and put single quotes, and now we will give the URL of our file, and it was file store, and within file store it was in tables, and within tables the name of the file was bigmartsales.csv. Now some of you will ask me, if we do not remember the exact URL, how we can get to know? There is a method, there is a function called fs, that is file systems. Yes, we can make use of that particular function and we can get the whole URL. Let me show you how you can do it. For that, let me create another cell. And how you can create another cell, just hover over this cell, just go a little bit up, you will see plus code plus text. If you click on plus text, it will create a markdown cell. If you click on plus code, it will create a code cell. Simply click on it and type a single line of code, that is dbutils. So these are some of the utilities that we get along with Databricks. So simply write dbutils dot fs, that is file system, then ls. Then we just need to define the container, that is file store. And we need to see what are the files available within this container. Simply run this. Okay, so as you can see this output, we have something called tables. Now we need to narrow it down. We need to see what are available files in this tables folder. So now we will say tables and we will say slash. We need to dig deeper inside these tables. Simply run this now. Okay, as expected. Now you can see the output and you have got your file name. It was so simple. So the file name is bigmart_sales.csv. So we need to add underscore here. See, it was so useful. Now we need to run this command, and if you want to see this data, you simply need to store it in a df that is called data frame. So let's run this command. Name true is not defined. Okay. Oh, so we have committed a small mistake. So we entered true in lowercase. So just be sure about it. Just keep this thing in your mind. Just use true with capital T. Okay, rerun it. Okay, now it is running. And now what it will do, it will just save the data into our data frame, which is df. Now I know you spotted something. I'm coming on that part. Do not worry. Okay. First of all, our df has that data. Now you have spotted this thing, Spark jobs, and now you can relate this thing with the information that we discussed in the slides. Let me give you an overview again. So we discussed that we have job, then we have something called stages within that. Okay, then we have something called task. Okay, so yes, in this particular cell we identified there are two Spark jobs. Okay, let's open it. Click on this arrow. Okay, so we have job 0, job 1. If you want to view it, simply click on view. I know you are very curious to view this. Okay, wow. So now let me expand it. Okay, so this is the information regarding our jobs. So within this job we have one stage. Oops, sorry. We have this one stage that is reading our data from the location. Then we have something called tasks, and there was only one task to pick this data, and it was submitted at this time, and duration it took to read the data 3 seconds. Similarly, you can have a look in job 1 as well. So this way you can have some extra information about the job. I know now you are feeling much more connected with the information that we got in the beginning of the video. Okay, now it's time to actually display the data. Okay, now here comes the trigger part. Okay, now it has created the df. Now we will trigger the action. So the trigger is, in our case, it's display. We have another trigger. Let me show you that first. That is df.show. I do not like the output of that particular trigger, so that's why I do not use .show, but I can just show you. So if you just trigger this part, then it will actually execute the code. Yes, simply click on df.show, and now it will show us the data available in that particular data frame. Ew, I do not like this output. See, it doesn't look good. It does not look good. So how we can improve the output? Wait, Databricks has launched another display option that is called dot display. Now just have the look. Wow, wow, wow. See, now it looks so good. So good, so good, so good. So I highly recommend you to use this particular show or display option. So this is our data that we have loaded successfully into our data frame. And now we will be seeing how we can import other file formats as well. Yes, this way we have seen to import data for CSV. Now, another real-time scenario where we need to import data from JSON format. So now we will see how we can import the JSON file format, and definitely we can create a different data frame for it. So for that, let's use the catalog tab here, and here we will upload our JSON file. I have a JSON file as well, so I will give you that file. You can upload it and we will read that JSON file as well. So this way you will be familiar how you can read multiple file formats. Yes, it is very handy, I know. So simply click on this catalog, and then same thing, click on create table, and then we need to upload our second file, that is JSON. So as you can see that we have successfully uploaded drivers.json file. This is a JSON format. Now let's see how we can read JSON file. Okay, that's interesting because JSON's output is not very much familiar to all the data enthusiasts. So let's see how we can read JSON file format. So simply go on workspace and select your folder, tutorial, simple. Then now we gonna read JSON file format. And you are right, we can create a different heading for that, and I will create that heading here. Let's say okay, and now I need to use text, so I will say data reading JSON. Okay, then if you click alt plus enter instead of shift plus enter, it will run that cell, plus it will create a new cell for you. So I will simply click alt plus enter. See, it ran the cell, then it created this particular cell for me. Another handy feature. So let's read the data. I will name this data frame as dfjson. Then I will say spark.read.format. So what is the format? Okay, yes, you are right, it's JSON. So we will simply write JSON. Then we need to define the option. Same way we defined it for CSV, and we want to infer our schema, okay, through. Then another option. Okay, let me share you another handy feature. What's that? Okay, so now you can see that we are writing the whole code in one line, and it doesn't look good when we have more and more options. How we can use another lines? Okay, so for that you simply need to add backslash, not slash, backslash. The key is available just above the enter. So simply use backslash, then hit enter to come on the next line. Then you can start continuing your rest of the code. So I will write dot option. So what it will do, it will tell Databricks, okay, this particular code is here, but due to the lack of space, Ansh has written down the code in the next line. So do not mind. Okay. So now dot option, we will say header equals true. Okay. Then here comes the game changer. Here we need to specify, because in JSON you must have seen that data comes in different formats. What do I mean? Some of the scenarios we get JSON in single line, where we have all the information available in single line for one record. Then second line will have the second record. So this way our JSON is stored in single line format. And for our scenario, it is single line JSON. You can simply double click on it and you can open it. And in some of the scenarios, it is multi-line, where it has hierarchically stored the structure of the schema. So we need to tell Databricks, see, bro, this is a single line JSON. So as we have just mentioned, we will write option and we say multi-line and we will say false, because this option we need to enable it when we have multi-line JSON, but for now we have single line JSON. So we simply need to write multi-line as false, simple dimple. Then we need to write dot load, and we know the location now. It's file store. Then it's in tables folder, and then we need to write the file name. It was results or riders. I don't know. Let's check it. See, that command is so handy. dbutils.fs.ls. Then I will say file store tables, then show me the files available. So it has shown me both the files, and we know that our second file is drivers.json. Okay, simply delete it. So I will say drivers.json. Are you excited to run this? I am very excited. So let's run it. Okay, now we want to see the data frame underscore JSON, how it looks. It looks beautiful. Okay, now we have successfully loaded this data. And if you want to see the original structure of the file, let me quickly show you. So it is this one, drivers.json. So as you can see, this is a single line JSON. So as you know that we have completed this particular phase, that is data reading, and we made the use of data frame reader API within Spark. So now it's time to jump on the next transformation, which is struct schema DDL schema. What are these? Let's discuss it. So we have this particular schema for our data frame, and as you can see, our first column, that is item identifier, is of string type. Okay, second column is of double type, third is for string type. So this is the schema that we have got when we defined infer schema equals true. What if we do not want Spark to automatically infer the schema? We want to additionally define the schema on our own to meet the requirements. Let's say I want to define this particular column, which is string, as integer. This can be one of the requirements. So for these kind of scenarios, we can define the schema additionally using two methods. There are total two methods. One is DDL schema, second is struct type, or you can say struct field. So we will be discussing both the scenarios, and my personal favorite is this one because this is easy and very quick to use. But I will show you this one as well, do not worry. So the scenario is we will convert maybe this column or this column to a different data type, maybe integer or double, that depends upon the data that we have. And then we will have a new schema based on our definitions. So this is the scenario, and we're gonna cover this in just few seconds. So we are into our notebook. Let's define a cell for schema. So I will add a heading and I will call it as schema definition. Let me first show you the schema that we have just seen in the slides. So how you can print your schema. There's a command, there's a function called df.print schema. Once you run this, you will see the schema. Okay, sorry. So you will see the schema. This is the schema that we have received when we asked Spark to create the schema. So now the scenario is we need to change one of the data types of our data. Let me look at the data. And there's another way to look at the data types. As you can see, ABC, that means string, 1.2, that means float or double. Then we have another 1.2. Let's say I want to convert this item weight into string. I do not want to save it as double. So for now, it is saved as double. Yes, I'm right. It is saved as double. So I want to save it as string. So how we can actually do it, let me show you. Here you just need to mention the same DDL command that you put in your SQL queries. So that's why I really like it. It's simple and efficient. So how we can do it, let me name it as my DDL schema, and then I will define the string. So obviously our schema will be populated in multiple lines. So for this, we need to use 3 single quotes and then we can write our schema. So first of all, as we know, we have this column called item identifier. That's it. And for this, we want to give the data type as string. Simple. Then we have second column. So let me write all the columns quickly to save the time. So let me close the single quotes. Now, as we just mentioned that we need to change this data type, the column, this one, item weight, from double to string. This is just an hypothetical situation where we are assuming that we need to change this column type and we do not want to use the schema that is defined by the Spark. So it's very simple. We can simply say, hey, I want string because this is my schema. I am the owner of the schema. So by this method, you have created your DDL schema. Simple. Now you just need to define the schema within your data frame reader API. And we have a function called dot schema. Simple. Let me show you. Do not worry. First of all, run this command so that we can save this whole schema in this particular variable. Now we will again read that data. I will say df equals spark dot read dot format, as our format is CSV. Then now instead of saying option infer schema, I will write yes dot schema. Oops, dot schema. So now we are saying Spark that pick this data with the schema. Now it is asking, okay, I can use the schema, but where is the definition? Then we say, hey bro, calm down. This is the definition, my DDL schema. So we just need to pass this variable inside this function, that is my DDL schema. Simple. Then we need to say, hey, make it header. Yes, it will create the header. So we need to enable it. So we simply need to write header, that is true. Then we need to give the path. So the path is file store, and within file store we have tables. Then we have something called big mart sales dot csv. So let's run this command using shift plus enter. Okay, it ran successfully. Now, are you excited to look at the data? Yes, we should be excited. df dot display. Data obviously will look same because we have changed the data type. Now, yes, we are successful. See, we have ABC, that is string type, instead of 1.2. See. Earlier we had 1.2. And we can also prove it by simply displaying the schema df dot print schema. Simple, 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 simple. So as you can see, now our column is of string type instead of integer or double. So this is the power of schema that you define by yourself instead of relying on Spark. So now let's quickly discuss the second method, which is very time taking and I do not like it, but still I can define for you so that you can learn. Okay, okay, very good. Keep it up, Ansh. Okay, so let's quickly write percentage %md and then we will say struct type schema. Wow. So here we need to make use of two functions, struct type and struct field. Let me show you how you can use it, and before using it we need to import some libraries. So for that I will say from PySpark.sql.functions. This is for importing struct field, or you can say struct type, because for types we use types here. So StructSQL.function.types, right? Import asterisk. Simple. So when you define asterisk, it will import all the functions, all the types. You do not need to worry about, okay, we need to define it again and again. No, just write asterisk and all sorted. Also write PySpark.sql.functions. This is for future use cases because we will be using lots of functions. So instead of defining it again and again, we can simply define it in the beginning of the notebook. Simply write import asterisk and run it. Simple and sorted. So now we will use struct type and struct field column. It is very easy. So how we can use it? Simply, I will obviously define the variable that is my struct schema. Now within this we need to use a function called struct type. See, it popped up because we imported the library. So simply use this function, use braces, then use a list because we will pass a list within this function. Open this list, hit tab to make it indented. So now we need to use a function called struct field. Okay, struct field. Now we will use this function. I know it is time taking, but just learn it, just grab the knowledge, and it's up to you which option you want to use. Either it is DDL or struct type struct field. So now we want to define the function for our columns. So let's say we have this column. So how we define it? We write the column name first of all, struct field. So struct field is item identifier. Then we need to give the data type. So what is the type we want? We want it as string type. So we write string type, that is the API within the Spark for string data type. Then we need to define that if we want nulls in our column. So if we want that we allow nulls in our that particular column, which is this one, then we can say okay, true. So we will write here simply true. So this is one column definition. See the difference? We just write whole line of code, whereas in DDL schema we just need to mention two words, name and type. That's it, sorted. So here we have successfully written the code for our first column. Similarly, I will write all the column names, and just to save the time I will just copy and paste. So now as you can see that we have mentioned all the columns and their data types, and as you can notice that I have changed the data types of all the columns to string to test it. So let's test it. I want to run it first. Yes, it ran successfully. So now it's time to run this again to use this particular schema into our data frame reader API. So let me quickly do that. df equals spark dot read dot format. CSV. Then we need to say, hey, pick the schema. That is my struct schema, and then dot option, header, make it true, simple. Then obviously the path, which is file store. Then we have tables. Then we have big mart sales. Simple. Let's run this. Okay. Oh, we did a small typo. Do not worry. So, oh, path does not exist. Oops. I forgot to mention the extension. Okay, it ran successfully. Let's look at the schema of this particular data frame, df.print schema. I expect to see all the columns as string type. Let's see. Yes, thank you so much. We are successful. So we have successfully transformed all the columns and we have changed their data types to string. So these were two methods. Which one did you like? Just tell me in the comment section. My personal favorite is DDL schema. Simple and sorted. So before jumping on to the next transformations, let me rerun this whole data frame again because we do not want to save all the data columns in the form of string. No, because we want to perform some aggregations as well in the near future. So let me quickly again read this data. Okay. And now we can rerun this command, that is df.print schema. Okay, sorted. So now it's time to look at the next transformation or next function within PySpark. Are you ready? Let's see it together. So here is our next transformation, which is select transformation. This is the most basic one, but it is really powerful and it is very convenient when we need to make selections on our data. So here is a simple scenario, simple use case. Let's see that data set. So this is, let's suppose, our data frame, and instead of having all the columns, that is item identifier, fat content, item type, item MRP, so I just want only these three columns. I do not want to pull the data for other columns. So to achieve this, we have a function called select, and yes, this is exactly same as the select command in SQL. So if you are already familiar with select statement in SQL, this is the exactly same thing that we need to do in PySpark API. So how we can do it? There are 2 to 3 ways. Do not worry. The function is one, that is dot select, but we have multiple ways to call the columns. So let me show you how you can do it. So we are back to our notebook. So as you have guessed it right, we will first create the heading. Headings are really important. So let's say select. That's it. Select is enough. So now what we will do, we have just mentioned that we want to just selectively pull the columns instead of all the columns. So let's say we want to create a new data frame that's called df cell. Cell is the short form for select. Don't mind my short forms. Df cell. Okay. So now we want to apply the select statement on the df, right? And this is our df. To just simply show the df, I can just write df dot display. Okie dokie. Okie dokie. So here we have all the columns, but I just want 3 columns. These are 6, but I want just 3. So let's pull these 3 columns. Yes, item identifier, item weight, item fat content. So I want to make a data frame based on just 3 columns. That is my scenario. That is my requirement that I have received from my stakeholder. So let's fulfill their requirement. It is very simple. What you need to write? Simply first write your df, that is your data frame. Then write dot select. Then here is the tip. So we have multiple ways to pull the columns. First, the simple unsorted way is just write the column name. that is item identifier. Then we have item weight. Okay, item weight. Then we have item fat content. Okay, instead of saving it, let's display it. So as you all know, we use dot display method. Now you know a lot of things, right? Now you know a lot of things. So let's run this. Booa. Yes. Now, as you can see that we got just 3 columns according to our requirement. Okay, this is very, very nice. So now let's see the second way of calling the columns. So this particular method is really handy because this will be used when performing some aggregations. So we make the use of COL, that is column object. Do not worry, it's your choice. If you want to use COL, you can use COL. If you want to use just column names, you can just use these column names. You have lots of customizations available in Spark. So yes, so I will simply write COL and I will encapsulate the column name within this object. Simple. Write COL and encapsulate the column name. Then write COL. It mentions that this is a column object. Okay. So if I run this, I will see the exact same output. See, it ran successfully and the output is same. So the choice is yours. If you want to use COL, then column name, okay. If you just want to use column name, then it is okay. I personally use COL. The reason is we need to use COL object with functions such as aggregations. So it is standardized. So I really like using it. So the thing is, we use COL object at the time of aggregating the data frames. So it is quite standardized when you use the single approach. So my personal favorite is using COL. Yes. So let's look at the other transformation that we have within Spark. So this is our another transformation that we want to use, that is alias. Yes, this is as similar to the SQL statement that we use as after the column name to give it a different name. Let's say we have a use case and we want to rename this column as item ID. So we can make the use of alias function. Yes, it is very, very easy to use alias in Spark. Let me show you how you can achieve it. So this is our scenario, simple steps. Let's see. To use the alias function, we just need to make the use of dot alias. It is as simple as that. So let me quickly write the heading. So we are using alias. So let me show you how you can achieve it. So let's say we are using select statement as we just discovered that, and we want to use column. See, here you cannot use alias function without COL object. So that's why I personally like to use COL object, because that is a column object. So we will write for COL, that is our column object, because whenever we want to use any function with dot, so we need to use the column object first, then it will be applied to that column. So we will simply write column, and our column was item identifier. Yes, we need to quote it in this particular single quotes, item identifier. Then let me zoom in. Then we simply need to write dot alias. That's it. Write dot alias. Then write your name. Not your name, the name that you want to give to this column. So I will say item ID. That's it. Let me zoom it again. Simple. Now if I just display this, it will give me the data frame with column name as yes, item ID. Let's run it. See, See, you just use alias function. Yep, you are learning really quick. So our this transformation is also done. Let's quickly see the other transformation that we want to learn. So we have our another transformation, which is filter slash where transformation. This is very powerful because obviously we need to slice our data based on the requirements, and it is row level slicing. So we have designed three scenarios, and obviously the first one is easy, second one is medium, third one is difficult. So we will be covering all the three scenarios. Sorry. So we will be covering all these three scenarios, and you will learn how you can perform filter on your data. And we will be covering Boolean expressions as well, as you can say or, and you can say some greater than less than operations are there. So this gonna be really useful for you, and let's get started. So here we are on our notebook. So what we need to do right now, we need to perform the next transformation, which is filter transformation. This is really important. And yes, we have created three scenarios, and we will be discussing all the three scenarios in detail. So do not worry. Let me quickly write a heading. Let's say filter. And within this filter, we also need to create another heading. Let's say scenario 1. So we will add another hashtag, scenario 1. So we have just seen that in our scenario 1. Let me quickly display the data first. Here, df.display. Perfect. So the scenario is we need to pull this data frame first. Then after pulling this data frame, we need to apply a filter transformation based on this particular column. Yes, and we need to fetch only those records where we have item fat content equals to regular. So we will be pulling only these records, and we will ignore all the other records. So this is our scenario 1. Let's quickly see how we can implement this to our data frame, and let's do it. So first of all, we will write df dot filter, that is dot filter command. Okay, then we need to write the column on which we need to perform the filter transformation. In our scenario, it is column item fat content. Yes, now comes the condition. What is the condition? We want item fat content equals to regular. Simple. Let me zoom it. So this is the condition that we have given to our data frame, and now we will run this, and you will see data is fetched just for item fat content equals regular. Okay, yes. As you can see, all the records have item fat content equals to regular. So our scenario 1 is achieved. Congratulations. Now we will be jumping on scenario 2. Okay, scenario 2. And what is the scenario 2? Let me quickly see it. So this is the scenario. This time we have two columns involved within our one filter condition. The columns are this one, item type and item weight. So we need to fetch those records which have, let's say, item type equals to soft drinks. Okay, one condition is fulfilled. and at the same time we need to pull the data which has item weight less than 10. Okay, so this is fulfilled for this record, but we cannot see any other condition that is being fulfilled in this particular small picture of data set. So this is the scenario that we're gonna achieve, where we will be combining two different scenarios, not scenarios, yeah, you can say two different filter conditions, and we will make the use of AND operator to combine both the statements. Let's see how we can do it. It is very simple. Let me show you how you can achieve it. So first of all, obviously we will write df.filter because we are going to create a filter on our data frame. So the first condition is column, which is known as item type. Okay, item type equals to soft drinks. Okay, we already know how to do this because we have already achieved the scenario, similar scenario in scenario 1. Okay, now as I just mentioned, we need to make the use of AND operator. And before applying the AND operator, we will encapsulate the whole condition. Let me zoom it. This whole condition, that is column item type equals to soft drinks, within braces, so that Spark will identify, okay, this is one particular condition. Okay, so let's encapsulate it like this. And okay, so now our this condition is acting as one whole condition. Now we will write here ampersand, which is the abbreviation for AND in Spark. Then we will write our second condition, which is in the braces. As you can see, we will write our condition in this braces, this one. So I will write column. My second column type is item weight. Okay, item weight less than 10. So this is my second condition, and then we will apply the final braces for this filter condition. So let me zoom it and explain it. So as you can see, this is our first condition, that is column item type equals to soft drinks, then ampersand, and then column item weight less than 10. So by this way, we have combined these two conditions, 1, 2, within this whole filter condition. See how easily we have achieved it. So are you excited to run it? I am very excited. Let's run it and see the result. Okay, so syntax error. Oh, so we just add two ampersands. We just need to add one ampersand. Okay, let's rerun it. We can see query returned no results, but we know that there was one record, right? Oh, just a typo. So we have added underscore in soft drinks, but there's no underscore here in the soft drinks. As you can see, there's space. Okay, let's rerun it, and boom, yes, we have successfully completed our scenario 2, where we have pull all the records which have item type equals to soft drinks, and at the same time the item weight is less than 10. So this was our scenario 2, and in this particular scenario you learn how to combine two different conditions using ampersand, that is an AND operator within Spark. So now let's start our scenario 3, which is hard, but we can just do it right like this. But we can just do it like this. So now it's time to look at the scenario 3, and I am very excited to have a look. Let's have a look. So our scenario 3 says that we need to fetch the data with tier 1 or 2. This is our first condition. Then we need to use ampersand, okay, for AND. Then we have our second condition, which is outlet size is null. So we need to use or and different conditions. So this gonna be really interesting. So let's get started. So let me quickly write %md for markdown. Then we have scenario 3. Okay, so let me quickly have a look. So what was the condition? Condition involved columns. First of all, location type, that is outlet location type. Then at the same time, outlet size. So we need to perform a transformation in which either the location type is tier 1 or tier 2. So we cannot include tier 3. Interesting. At the same time, they want just to fetch the null records in which we have nulls in this particular column. Okay, this is really interesting. So are you excited to learn this transformation and complete this scenario? Yes, let's do it. So to perform this task, we will be using 2 additional functions within our filter transformation. What are those functions? First of all, we will use dot is in function. Yes. Then we will use dot is null function. So as you can see that we need to perform, first of all, the first transformation is this one, in which we need to insert tier 1 and tier 2 in this particular function. Then we need to insert our column in null operator because we just need to fetch outlet size equals null records. So yes, this is gonna be really interesting. I am really excited to type the code for it. So first of all, df dot filter. Woohoo! So now, yes, you guys did right. We need to create condition number 1. So we add parenthesis. So condition number 1 is column with name outlet size dot is null. So what it will do? It will just fetch the records in which we have nulls in this particular column, outlet size. This is our condition number 1. Okay, and at the same time we need to perform ampersand. That is our second condition. So I will write column outlet, what is the name of that column? Outlet location type. Okay, outlet location type. Okay, now we will use dot isn't function because we want our column, which is outlet location type, should be in either tier 1 or tier 2. That's it. Okay, so let's perform that function. So we simply need to write dot is in. Okay, the function name popped up, is in, then parenthesis. Then we need to write both the values, that is tier 1 comma tier 2. Simple. Let me zoom it. Let me explain it again. Condition number 1 is column outlet size is null. That means we want nulls in that column. Okay. At the same time, we want column outlet location type should be in tier 1 or tier 2. That's it. So this was the whole condition that we have created, and now we will run it. Dot display. Woohoo! First of all, congratulate yourself because this was not easy to perform and you have learned great transformation in the scenario 3. Okay, so congratulations. Let me see. Okay, now we can see that our outlet size is null and outlet location type is either in tier 1 or tier 2. So both the conditions are met. So we are good to go. That's it. So did you like this scenario? I really liked it. So now it's time to learn the another transformation. Let's learn it. So here we are going to perform our next transformation. Just that is with column renamed. So as the name suggests, it helps us to rename our column. It is different from areas because in the areas we just give the new name to our transformated column, but in this particular function we can change the column name at the data frame level. So we will change the name of this particular column, let's say item weight, to just have like item WT. That's it. So this is our scenario and we gonna do it like this. So here we are into our notebook. So we will simply create a new heading. Let's say with column renamed. Okay. And now we need to use this particular column. How we can do it? Let me show you. So we will say df dot with we already got the function. It was popped up. So it is df dot with column renamed, and then you need to give the column name. So let's suppose our previous column name is this one, item weight, and we need to give the new name, which is item WT. That's it. Let me zoom it for you. See, this is our previous name, this one, and this is our new name. It's so simple. Let me run it and display as well at the same time. Okay, as you can see, our column name is changed to item WT, and we have just mentioned that this changes our column at the data frame level. So you can use item WT for the, you can say, future transformations, and this is really handy where you need to change the column name during applying joins. Do not worry, we will see how we can apply joins. So just stay calm and have some water, because water is really good for health. So after this, let's learn another transformation. So here is our next transformation, that is with column transformation. I know this sounds similar to the previous one, which was with column rename, but this is very different. Plus this is very powerful. So the scenario is we need to create a new column here. How we can achieve it? Here we have this function called with column. The second scenario, we need to modify this column. Then also we need to make the use of this particular column, or not column, like with column function. So this helps us to create the new column. Plus if we want to modify any column that is already existed in the data frame, we can do that using this massive function, that is with column. So scenario one is this one, new column, and scenario 2 is this one, modify. Modify column. So we have two scenarios for this transformation as well. So first of all, we will create a new one, then we will modify the existing one. So let's see how we can do it. Let's jump to the notebook. Okay, this is our notebook. Then it's time to create a new heading, that is with column. Okay, then we will create two scenarios. Scenario 1. Scenario 1 is creating a new column based on any existing columns. Maybe it can be a new column. Okay, so let's create a new column. I want to use this data frame, right? And I want to create a new column in which I will simply put a constant value. Let's say anything. Let's say I want to create a flag column in which I will put the value as new. That's it. That is the requirement. So let's create a new column. So df equals to, because we are going to save this particular column into our data frame. So df equals to df dot with column. Again, the function popped up. Then here we need to give the name to our new column, because obviously we need to define the column. So what is the name? I want to name it as flag. Then what transformation we need to perform on this particular column? So we want to use a constant value called new. So do you really think we can just write, like, let me do it for you. Like, I will type it like this, new, and it will take this value? No, no. Spark does not do this. So if we want to make constant value in the columns, we need to make the use of a function called lit. What is the name? Let me repeat. Lit. The function is lit. So this is another transformation that you are learning within this transformation. So we need to use lit function, lit, and encapsulate the value, the constant value that you need to use, and then it is sorted. Let me run it. Okay, it ran successfully. Let me show it. Finally, yes. See, I got a new column called flag in which I have the values such as this. New. So if you want to create a column in which you need to store a constant value, then you have to use lit function within that. So now it's time to create a new column based on some transformation. Okay, so that is not our scenario 2. Let me clarify this. So we are creating a new column. Instead of putting a constant value, we will do some transformation. So let me show you what do I mean. Let's say I want to multiply item weight with item MRP, these two columns, item weight with this one, item MRP, and I want to create a new column based on the product of these two columns. That is the common scenario, right? Let's do it. So I will say df dot with column, and then I will name it as multiply. Okay, then as you know, we need to define the transformation performed on this particular column, that is a new column. So we want to do column item weight product column item MRP. Simple. And then we will say display. Okay, now I am expecting a new column called multiply to have the product of both the columns. I got it. So here I can see a new column called multiply, which is the product of both the columns. That is this one, item weight and item MRP. This was so simple. Let's jump on to the scenario 2. Let's create a new markdown. Scenario 2. And as you remember, in the scenario 2, we are going to modify the existing column. So what is this scenario? So I want to change the content. Yes, I want to write LF instead of low fat. I want to write REG instead of regular. I want to write, we just have two options right now. So I think you got the requirement. We need to replace the values. This is not kind of replace. So we are just, yeah, you can say this is a replace because we are replacing the value that is low fat with LF and regular with REG. So we are going to perform this transformation on an existing column and we will not create a new column. So our column will remain the same. Only the contents are going to be changed. Are you excited to see this? Let me show you. So how we can do it? Let me show you. So we simply need to write df dot with column and then we will give the name to this column. So this is the point of difference between creating a new column and modifying the existing one. So if you give the same name, that is item fat content, so it will modify the existing column. If you will give a new name, then it will create a new column. So that is the only difference you need to take care of. Once you have given the column name, then it's time to perform the transformation. So in this particular transformation, we will make the use of a function called regexp replace, which is the function that is used to replace the column values. And that is a very powerful function. So we will be learning two functions within one scenario. That's good. So simply write regexp replace. Okay, that is popped up. Then we need to define the column, on which column we need to perform this particular function, that is regexp replace. The column name is item fat content. And then we need to define the previous value and the value that we need to provide. So first of all, we want to say the previous value is regular. And can you please replace it with the value called reg? So what it will do, it will just replace the value that is regular with reg. So let me display this data first. Okay. So we successfully transformed our column with reg. So if we want to change the value for low fat, yes, we can do it. For that, we need to again perform dot with column transformation on this particular df. How we can do it? Simply put slash at the end because we cannot perform the whole transformation in one line. So let's hit enter, then again write with column. So now what it will be doing, it will first transform this particular column, that is this one, and the name is item fat content because we are modifying the existing column. So once this transformation is done, this one, then we are saying, hey bro, wait, we are providing you another transformation. So here again we will write the exact same thing. Okay, and this time we need to change low fat with LF. Simple. Let's display this now. Okay, so it has successfully changed our column, transformed our column, and as you can see, LF for low fat, regular, reg for regular. So you have successfully completed this particular transformation as well. Now it's time to learn another transformations. Let's learn it. Now it's time to look at our new transformation, which is typecasting. This is the kind of transformation that we use very often. So the thing is, it helps us to cast our columns. So it is very handy when we need to apply joins because we need to apply joins on the same column type. And I think when we need to perform aggregations as well, then we can just convert the data types from one to another. So this is very, very handy. So let me share this scenario with you all. So the scenario is, let's say we want to convert this value as string or maybe this value as string. So we will convert this data type to string. So we are basically typecasting the data types. So how we can do it? It is very, very easy using only one line of code. Let's quickly have a look on this powerful typecasting function to cast our columns from one data type to another. Let's see. Let's jump onto the notebook, and here I can see my notebook. Then I will say typecasting. Okay, so how we can do it? First of all, let's modify a column. So it will be a quick revision for you to modify a column and convert its type. So let's save this into df dot with column. Then name the column same as we already have in our data frame, item weight, and we need to convert its data type from int or double to string. So we will use column, and then we will say item weight. Then we need to use cast function. Let me type it here first for you all. Dot cast. This is our function. Okay, so we will write dot cast. Okay, and in which data type we need to cast our column? We need to cast our column to string type. So here we will write string type. Simple. Do not forget to add parenthesis after the string type because it is an API. Okay, all sorted. Let's run this. Okay, it ran successfully. Let me have a look on the schema. Right now, I should see item weight as string. Is it this scenario? Yes. So we have successfully converted or cast our column type from int or double to string. See, it was very easy, but it is very handy when you will be doing some real-time scenarios. You will be using this particular function very often. So just keep this function in your mind. Let's learn another function. So now finally we are going to learn this transformation, that is sort slash order by. So as the name suggests, we are going to perform sorting on our data frame. So why we use this function? Let's say we want to sort our data, or we want to arrange our data in such an order that we want to define this data frame in the ascending order based on this particular column, that is item weight. Or I want to arrange my data frame in the descending order based on this particular column. Or let's take another column. Let's say this one. I want to arrange my data frame in such a way that I want to store my data frame in the ascending order based on this column. So in all these scenarios, we make the use of this function, that is dot sort or dot order by. And there are multiple scenarios, such as, let's say I want to perform order by based on both the columns. Yes, we can do this in Spark using this particular function. So let's see how we can use this function, and we will be covering 2 to 3 scenarios, and we will learn to perform order by or sorting on our data frame using this function. Let's see. So now we are in our notebook. So now it's time to learn order by slash sort. So let's quickly create a new heading. So this time we need to say dot sort. Okay, so now we will be discussing 2 to 3 scenarios so that we can grasp this function to the fullest. Okay, so first of all, let's write scenario 1. Perfect. Okay, so what is this scenario 1? Let me show. So first of all, this is our data frame. This is our data frame. I want to sort my data frame based on this column in the descending order so that I can see my data frame, and the first record will be the highest weight, will have the highest weight, right? and then it will keep on descending. So how we can do it? For that, we need to use a function called dot sort. Within that function, we will make use of another function, that is dot asc slash dot desc, to define the order. Simple. Let's quickly do this. So df dot sort, simple. Then we need to define the column name on which we need to perform the sort. So we need to perform the sort on column item weight. Okay. Then here is the thing. If we want to perform descending, if we want to sort our data in descending order, then we simply need to write dot desc. Simple. Let me zoom it. Simple. df dot sort, that means we are going to apply a sort on our df, then on which column we need to perform, then dot in which order, ascending or descending, we need to perform our order by in descending order. Simply run this and we need to display the data. Woohoo! We got the result. So as you can see, our data frame is sorted. It's sorted based on item weight. So here comes the scenario 2. Let's suppose we want to perform ascending order on this particular column, that is item visibility. So I want to see the item with the least item visibility as my first record. So how we can do that? Let me quickly type scenario 2. Oops. Scenario 2. So we will write df dot sort, then on which column we need to apply, it's item visibility. Yes, it is item visibility. Item visibility. Then we need to apply ascending order. We need to apply the sort of function in ascending order. So we will simply write dot asc. If you will not write anything, it will take ascending as the default value. So it's a good practice to write. So we will write dot asc. Now we need to write dot display. Simple. Wow. Wow, wow, wow. As you can see, we have received the records and we can see 0, that is the least value for this column, and our data frame is sorted based on this particular column. Now comes the scenario 3, and it is a little bit advanced version, because in this particular scenario, let me show you. In scenario 3, we want to perform sorting based on multiple columns. Yes, based on multiple columns. Let's say I want to perform my order by on this column in descending order, in this column in descending order as well. So how we can apply sorting based on multiple columns? It is very easy. Let me show you how you can do it. So we will simply go to our cell and we will write df dot sort, and then we will write the list of columns that we want. First column is item weight, then the second column is item visibility, and then we can define here column, comma, then we need to tell in which order we need to perform sorting. So here is a new tip, that is you can simply write ascending equals to, here we have two columns, so we need to define a list. So for first column, we need ascending equals to false, because we are performing order by in descending order. So we will write ascending equals to 0, that means false, that is a boolean value. For second column, it is false. See, 0 0. Now we need to display it. Okay, let's see our data frame. Okay, yes. So this was expected. So now our data frame is sorted based on this column and this column, and both the columns are ordered by in descending order. So this was so simple. Let's discuss one more scenario where we need to perform sorting in descending order on this column, but sorting in ascending order on this column. So this is a kind of real world scenario. So let's discuss it. It is very simple. You just need to make a small tweak. So we can simply write here scenario 4. Scenario 4. Yep. And in this one, we will apply df.sort. And again, we need to pass a list. That is, first column is item weight. Okay. The second column is item visibility. So as we have just discussed that we need to perform order by or sorting in descending order on first column. So we will say 0, but we need to perform sorting based on item visibility column in ascending order. So we will say 1, that is true. That is a Boolean value for true. Simple. Now we need to write display sorted. Our data frame. Oh, what do you mean? Oh, we forgot to mention equals to sign out of curiosity. So sorry for that. Our data frame is sorted. So as you can see, this column is sorted in descending order. Then this column is sorted in ascending order. So now you can see we do not see 0 because this is based on this column 4. So this data frame is sorted. Let me tell you, based on this column. So first it will sort our data frame in descending order based on this column. Then it will check the values for this particular column. And then it will sort our data frame in ascending order. So as you can see, we have multiple values for item visibility for 9.895. So first it sorted our data based on this value. Then it said, okay, we have multiple values. Then we need to perform ascending order. Then we need to sort our data in ascending order based on this column. So as you can see, the values are in ascending order. So this is the power of using sorting based on multiple columns. So this was a real world scenario. I hope you liked it. So let's learn the next transformation, next function. Let's learn. So here is our new function, limit. So as if you are already familiar with pandas library, this is something similar to head function. If you are familiar with SQL, this is exactly same as limit function is in SQL. Why do we use this function? Why? So if we do not want all the records, such as C, I do not want all these records, and I know there are so many records here as well. So if we do not want all the records, and if I just want to use, let's say, 5 records, so we can make use of limit function to just get the 5 records. So let's see how we can use this function in PySpark. So here we are in our Jupyter notebook. Oops, this is not Jupyter notebook. That just came in my mind when I just talked about Jupyter. So this is our Databricks notebook. So first of all, we will write limit. So just one announcement, do not worry at all. I will also attach the link to download this notebook so that you can refer it along with the masterclass. So do not worry at all. So first of all, we want to limit our df. Let's say df dot limit and then 10. Let's say I just want 10 records. That's it. And we will say dot display. This is a simple, sweet, cute function. So df dot display, and we will see just 10 records. See, we just got 10 records. Simple, sorted, sweet, cute function. And yes, it is very handy. You will be using this function as well. So this is it about limit function. So now you have learned so many functions, and now you can see yourself growing as a pro, as a hero in PySpark. But yes, there are lots of transformations, functions that we need to learn. So just be with this video, but do not forget to congratulate yourself because you are learning so many important stuff in this domain. So let's see the another transformation. So it's time to discuss another powerful function called drop. So as the name suggests, it is used to drop the columns. So let's quickly discuss the scenario. Let's suppose we have this data frame having these three columns and we do not want this particular column. So we can make use of drop function to eliminate this column from our data frame. Now, another use case, if we want to drop multiple columns in one go, we can still use this function. So let's see how we can use this function. So first of all, as we know, we will mention the headline. So let's quickly add the headline. So we will add drop, and then here is our scenario as we just discussed. Let's say we need to eliminate this column from our data frame. This is our scenario 1. And in our scenario 2, we will drop two columns together. So first of all, scenario 1. Okay, scenario 1. So it's very simple. Let me tell you the syntax. First of all, you need to mention the data frame because we are dropping the column from data frame. So we will write df dot drop, that is our function name. Then we just need to mention the columns. That's it. It is that simple. So I will write item visibility dot display. Simple. Column is dropped. Simple dimple. Now let's discuss the scenario 2 when we need to drop multiple columns. And let's quickly write scenario 2. So now we will simply write the code, that is df.drop, and then we will write all the column names that we want to drop. Yes, it is very simple. So let's say I want to drop item visibility and I want to drop item type. Simple. See, now we do not have any of those columns. So it is very useful when we need to filter our data based on the columns and we want to drop some columns that we do not want to use. Simple. So let's learn another function in PySpark. Let's talk about another powerful function in PySpark, that is drop duplicates. Why do we use this function? What is the use case? Let me tell you. If we have duplicates in our data frame, we can remove them with the help of this function. Okay, let's suppose we have this particular row and we have exact same row here as well, and we do not want duplicates in our data frame. So we can remove this duplicate with the help of this function. Second scenario, let's say we do not want to drop the duplicate for all the columns. Let's say we just want to remove the column, or you can say the duplicate that we have in this particular column, in this one. As you can see, we have duplicate values here, snack foods and snack foods. And I just want to drop my records where we have duplicates in this particular column. So in these types of scenarios, we can use drop duplicates function, and we have multiple options that we can use in addition to this particular function. So let's see how we can use this function in our data frame. So here we are in our PySpark notebook. So let's first of all create the heading for this particular transformation, and transformation is drop duplicates. So as we just talked about, if we want to drop the whole row which have duplicates in all the columns, we have two options to use this. First of all, simple write the data frame df dot drop duplicates. As you can see, we got two options. One is without underscore, one is with underscore. So in pandas library, we use with underscore, so you have both the options. I prefer using without underscore, so it's up to you. Df dot drop duplicates, simple. And if we want to see, we can display it. So when we run this function, that means our all the duplicates are removed. So this process is also known as dedupe. If an interviewer asks you how to dedupe the data frame, you can simply say that we can use drop duplicates. Now let's talk about the second scenario that we just discussed, when we need to remove the duplicates based on a subset of columns. Let's say I want to remove duplicates based on this column. Just an example. Whenever I see duplicate in this column, I want to remove all the records. Simple. So in that particular scenario, we can use the option called subset within this particular function. Don't worry, syntax is really simple. Let me show you how you can achieve it. First of all, we will type scenario 2. And here we will drop duplicates based on this particular column, this one, item type. Okay, let's do that. So df dot, and this is the kind of scenario that you will face in day-to-day activities, because not every time you will drop duplicates based on all the columns, but yes, many times you will just drop duplicates based on subset of the columns. So it totally depends upon the requirements. So I am sharing both the scenarios with you all so that you can perform each and everything without any issues. So this time let's use underscore. So if you want to use pandas like function, so let's use this one this time. Df dot drop duplicates. Now we need to write subset. See, as you can see, I am already getting a suggestion that I can give my subset. So always keep an eye on the suggestions that you get while coding. It will definitely help you a lot. So let's write subset equals to, now I just need to pass the list of columns that I want to include in my subset. This time I just have one column, that is item type. So I will just include one, and let's show dot display. Now what it will do, it will remove all the duplicates from this particular column, and it will just give me the distinct values. Very good. Let's see dot display. Let me run this. Okay. I think yes, we are good. As you can see, we are just getting 16 rows instead of 8,000 plus rows, because now it is removing all the duplicates which were there in this particular column. Simple. So if you want to include multiple columns, you can simply add your column list here and you are good. See, it was very simple, but it is very helpful, because in the world of big data, we do get duplicates very often. So it is the prerequisite to process your data. First of all, dedupe your data, because you do not know if you have duplicates in your data frame or not. So it is the best practice to dedupe. So we have covered one real-time scenario as well. That is, what is dedupe? Dedupe is a fancy word, but Concept is very simple. So this was all about drop duplicates. Hey, I have one more function which is very similar to this one, just the difference in name. So if you do not want to use subset, this one, if you do not want to use subset, you just need to drop duplicates based on all the columns. You can also use a function called distinct. Let me show you. So you just need to write df dot distinct, simple, that you also do in SQL. So just write distinct and then write dot display. So this will do the same thing that we have done with drop duplicates without any subset. So by default, it will take all the columns. See? So if you like this function that is distinct, you can use this function. I personally prefer drop duplicates, but it's up to you. My work is to give knowledge about each and everything. The choice is yours. So this was all about dropping the duplicates. Let's see another function. So now it's time to discuss about the union function. So as we all are aware of this function, as we must have read this function in mathematics, so it is exactly similar to that one. So what this function does, so if we have this data frame and we have this data frame, so these are basically two different data frames, and we want to apply union between these two data frames. So we use this powerful function, that is union. Oops. Then we use this powerful function to apply union between these two data frames. How does it work and what is this union by name? I know you want to know a lot of things related to this particular function, so I will tell you each and everything in PySpark notebook. So without wasting any time, let's learn this function. So here we are on our PySpark notebook. So as you can see that I have prepared my data for this special function because I wanted to show you both the features, that is union plus union by name. So for that, I have prepared two data frames, and don't worry, it is very simple. Let me give you a walkthrough. So first of all, we have defined data that are just the records, and then we have defined schema as we have already discussed about this, and then we made use of this particular function, that is create data frame, to create our data frame. So this is the code, and do not worry, you can just copy and paste this code to your notebook using my notebook, and you will see data frames like this. So this is my data frame 1 and this is my data frame 2. Simple dimple. Now according to the requirement, we need to apply union between these two data frames, between these two data frames. So I'm just creating a plus sign here because we need to basically add these two data frames as it is. So we will make use of union function. So what it will do, it will take my data frame 1, that is this one, and it will take my data frame 2, this one, and it will just put these columns one after another. That's it. You can say it will just tag my both the data frames, simple, without any join condition, without any checking of columns. It will just tag my two data frames one after another. That's it. This is the logic behind union function. So how we can perform it? First of all, we will write union, and don't worry, I'm telling you what is union by name. Don't worry, calm down, calm down. So first of all, we will write union, and in union it is very simple. You first need to write your first data frame, that is df1, then you will write union, then brackets, then you will write the other data frame, df2. Simple. Yes, simple. Then you want to display the data. Obviously we want to see the data. Okay, let me show you the data. Simply write display and then run it. And now you will see, perfect. It has applied union function between our data frames. Now let's talk about union by name. As I just mentioned that this is my data frame 1 and this is my data frame 2. So it didn't check anything. Anything means anything. It just tagged my both the data frames. Let's suppose my data frame 1 looks like this. Let me create data frame 1 again. Let me just copy paste this, and I'm just changing the order of the columns, and I will tell you the difference. And this is an interview question, so just put some more focus in this area. So I'm going to create df1 again, and this time I will reverse the order. I will first write name and then I will write the ID. And now you will see the difference and why we need union by name function. Okay, name and ID. Let me create it and let me show you as well. So now as you can see, my df1 looks like this. Name column appears at the first and ID column is the second column. Okay, now if I apply union function, it will mess my data. Let me show you. df1 dot union df2 dot display. It will mess up my data. Just see, because it does not know how to compare the columns. See, in the first column I'm seeing name and then IDs. Reason, because for my data frame 1 I have name first and then I have ID, but in the second data frame I have ID first and then name. So mess. And do you know how we can just clear this mess? It is very simple. Now we have a function called union by name, and I think you have guessed it already how it will work. It will compare the data frame based on the column names. So what it will do, it will say, okay, you have name column first in your data frame 1, okay, and you have name column at the second position in your data frame 2. So I will take care of it and I will map the data accordingly. So now I will show you the magic. So now I will write union by name. Oops, union by name. Yep. So it is very simple. Syntax is exactly same. We just need to write union by name and that will be popped up. Let me show you df1 dot union. As you can see, union by name. Simple. Just write df2. Now, no mess. No mess means no mess. Perfect. So this function is really handy when you have the order of columns different from the other data frame. So Spark will take care of all the mappings. So I know this was a new learning for you because union by name function is not available in all the languages. So this is available in PySpark. Make use of this function. I personally use this function a lot, so it is a very good one. Plus, it will definitely be asked in the interviews, I'm sure. So now you know. So you can thank me in the comment section. Welcome. So let's learn the new function now. Now it's time to talk about the string functions. So as you must have worked with Excel, and we use these functions very often like init cap, upper, lower. We have these functions available in PySpark as well. So let's see how we can use these functions. These are very simple, but I think these are very powerful when you want to just apply joins and you want to make sure that values within columns are matching, which are in string format. So I think let's cover this particular area because this is really important. So let's learn this. So it's time to practically use those functions. Let's look at our data frame first, and then we can just decide which column we're gonna use for this particular function. So I think this is the best column, item type. First, we will use initCap functions. So what initCap function does, it is similar to the proper function that we have in Excel. I haven't used Excel much, but I think this is similar to that one. Then we have lower, as the name suggests, it will just convert all the text in the lowercase. And then we have upper that will convert the whole text in the uppercase. Let's look at the three scenarios that we have just discussed and learn this function as well. So as you all know, first of all, we will create our heading because this notebook will be used by you all, and I want everything is sorted, looks good, so that you can learn better. So first of all, we will write string functions. Perfect. And then I can write, first of all, initCap function. So I want to use initCap on item type. So df dot select, and I will write first of all I will write initCap. So as you can see, the function popped up, initCap, and then I need to specify which column I want to use within this function. I want to use item type. Simple. And let's display this data. Oh, as you can see, it has converted all the text in the proper format, which is also known as initCap in PySpark. So as you can see, the alphabet A in the and is also converted into the uppercase, the first alphabet. That is, I think, similar to the proper function in Excel. Then let's use the lower function. Okay. Yes, it has converted all the text into lowercase. Let's use the upper function. So I'm just converting the function here. Yes, so now it has converted all the text into uppercase. This is very handy when you are, let's say, applying a join on this particular column, and the data frame has this column in uppercase and you have this column in lowercase. Then you have to exactly match the values and you have to use this function. Okay, let's also use the alias function because it doesn't look good. Like, what is this upper braces and then curly braces and then, oh sorry, not braces, parentheses, then item type. So let's use alias function as well, and it will be a good revision for us because we have already covered how to use alias function. So we just need to write dot alias after our column name, and I will say upper item type. Perfect. So this was just for your revision. See, so this was very easy, I know. So let's learn the other function available in PySpark. Now it's time to discuss the most crucial part of PySpark is date functions. Being a data person, you must be aware of how hectic it is to manage the date columns. It is a task, but let's learn the powerful functions available in PySpark so we can efficiently manage the date columns. So as you can see on the screen, first of all, we have current date. As the name suggests, it gives us the current date. It is very handy when we need to compare the dates or we need to create a different column with this particular date. So it serves that purpose and it is very, very handy. Second is date add. If we want to add date to our columns, let's say we have one column, order date or any column, and we want to add, let's say, 7 days to that particular column. So we can make use of date add function. It is very handy. Then we have another function that is date sub. I personally don't use date sub function because I have a workaround and I will tell you what is that and you will love that, and you will also use just date add function. Now you will say, hey, if I want to subtract the values, subtract the number of days, wait, I just said that I have a workaround for that, and I will tell you how you can efficiently use all these functions. Let's learn that. Now it's time to cover the date functions. So first of all, we will just put the heading that is for date functions, and we will get started with our first function, that is current date, and we will create a column. Yes, let's create a column, and we will just store the current date in that particular column. So let's say df equals to, okay, I forgot to mention the heading, so sorry for that. Let me write current date. So df equals to df dot, okay, a quick question for you. If I want to create a new column in my data frame, how I can create it? You have 3 seconds. 3, 2, 1. Okay, you guessed it right. We need to use with column function. Df dot with column, and then I will say now, or let's call it as current date, and I just need to use this function current date. You just saw that it was popped up. Let me show you again. Current date, simple, and it's done. And I can also show you the data by writing df dot display. Okay, our data is ready. Let me see that column that we have just created. Perfect, perfect. I can see the current date in my column. Perfect. Now it's time to cover the second function. So what is the requirement? The requirement is very simple. We need to add 2 days in this particular date, and we will create a different column and we will call it as future date. Or let's add 1 week in this particular data frame, or sorry, in this particular column in this data frame, and let's call it as 1 week after. Okay, sorted. Let's cover that scenario, and we will say date add function. Okay, so it is very simple. So first need to write df dot with column, and the name of the column will be week after. Okay, perfect. Now how we can do it? Simply need to write date add function. See, it popped up, date add. Now in which column we need to add date? That we have just created, current date. Now how many days we need to add in this particular date? 7 days. Okay, now let's see the data. Now perfect. Now you can see 1 week or 7 days are added into my current date column. Now let's discuss the third function, that is date sub. As the name suggests, that it gonna just subtract the 7 days from that particular column, and I have a workaround for that I personally like a lot to use it. So let me show you how we can do it. So I will first show you how we can achieve this scenario in which we need to remove 7 days from our date column using date sub function. Then I will do the same thing using date add function. It is a small tip, so just wait and watch. First of all, let's cover the date sub function. Date sub. Okay, now let's create a column, df dot with column, and I will not save it in my data frame because I'm just showing you df dot with column, and I will say week before, and I will use date sub function. Okay, the column obviously will be cure date, and what we need to, like, how many days we need to subtract? 7. Simple. And display the data. Simple. Let's see. Obviously it will just subtract the data, and then I will tell you my workaround that I personally like to use, and that is quite professional because I have seen everyone using that thing. So see, it has reduced the 7 days. from my cur date column. Now I want to achieve the same thing using date add function. Let's do it. It's very simple. So what I can do, df equals to df dot with column, and I will say week before. Okay, and then I will add date add. Okay, obviously I want to use cur date column. Now how many days I want to add? I'm just repeating. I know I want to subtract 7 days, but how many days I need to add? Minus 7. Simple mathematics. Minus 7. So when it will add minus 7, so automatically it's gonna subtract it. So it's just a small tip. So let's display the data, and I should see the same result that I got using date sub function. Woohoo! Yes, we got the same result. We can see that it has subtracted 7 days from my cur date column. So it was a small tip, but it is very handy. And yes, so now it's time to look at the next transformation, next function available in PySpark. Now it's time to cover my favorite function, that is dateDiff. Yes, why it is my favorite and why we use this function, let me tell you. So I have encountered with lots of scenarios where we want to find the interval between two different date columns, and that's where we use this function, that is dateDiff. DateDiff means date difference. So it will give us the difference between date 1 and date 2. Let me create one scenario. Let's say we have current date, okay, that we have just created, and then we have this column week after, and we want to know the number of days available between these two date columns. This you can relate it with your, let's say, real-time scenario, in which this can be wait this can act as an order date, and this can act as your cancel date. So we want to know the interval, like after how many days customer just cancel the order. There can be infinite scenarios. My task is to just give you the precise knowledge so that you can apply this knowledge in all the scenarios. So we want to know the difference between this column and this column, and we want to know the number of days available between these two date columns. And let me tell you how we can do it. It is very simple, but it is very useful, and it is my favorite date function. So let me tell you how we can do it. So it's time to just apply my favorite date function, that is dateDiff. And first and foremost thing, heading. Okay, let's write dateDiff. Okay, so as we have just discussed that we will create the column, the new column, which will give us the difference between these two columns. Okay, let's quickly create a column. It is very simple. So df equals to df dot with column, because we are creating a new column, and I will name it as dateDiff. Do not get confused, this is not a function, this is just a column name. Okay, oh nice. Then we need to specify the column, that is dateDiff. Okay, as expected, it just popped up. So in this, now we need to, and oh, let me show you one thing. As you can see the suggestions. So here we first need to write the end date, that is our bigger date, second date, whatever you can say. Second thing is start date. Because if we want to find the interval between two dates, we need to just give the end date and the start date. So in the end date, what you will mention? Yes, you guessed it right. We will mention the current date. And in the end date, or sorry, in the start date, we will mention the week before or week after, whatever the column that we're gonna use. So it will give us the interval, the number of days available between two dates. Let's see how we can do it. So the column names are cur date and week after. Okay, sorted. So here I will first write my first column, that is cur date. Then I need to give the second date, which is week after. Simple. And let's display this data. Oops, sorry. Let's display this data, df.display. And now I should see the number of days available between two columns. It is -7. Okay, perfect. Because this is the current date and this is the week after. So that means there's a difference of 7 days, and this is the smaller date, this is the bigger date because this is the future date. So that's why when we subtract this column from this column, we see -7. If we want to see +7, then we can just switch the columns. Simple. So I can keep my week after column as my end date and my start date is current date. Let's display this data again. Now you can see that we see number 7, that is 7 days. So by default it gives us the number of days available when we do the difference between two date columns. So this was all about the date difference column, and let's see another powerful date function in just few minutes. Here we are with another powerful date function which falls under the bigger umbrella of date functions, which is date format. This is very handy. You will say all the functions are handy. Yes, if you are a PySpark developer, if you are a big data developer, all the functions are handy because there is so much to transform. So this is a very powerful function. Why we use this function and why this function is there? Why? Let me tell you why. So let's suppose we have this particular date column. Yes, we know we just created it. It gives me date format like this, YYMMDD. I do not like this format, or let's say my manager doesn't like this format. I want to change this format. I want, let's say, MMYYDD or DDMMYY or any format. So if we want to change the format of a date column, we can use this function, that is date format function. So in our scenario, we will change the format of this particular column, maybe current date, week after, week before, any column, and then we will see how effectively it changes the format without any hustle. So let's see how we can do it in PySpark. It is very easy. So here we are in our PySpark notebook. Let's learn this date format function. And as you know that I'm gonna put heading first, date format. Perfect. So in this particular function, we will, let's say, create a new column in which we will not new column. Let's transform this column. Okay, let's transform this column and we will just change the format of the date. Okay, let's do it. It's fun. Okay, how you can transform a column? 3 seconds. 3, 2, 1. Perfect. We can make use of with column with same name. Perfect. You are learning good. So df dot with column, and then we will provide the same name, that is week before. Because when we just a quick revision, when we use with column with the same name, this one available in data frame, it modifies the column instead of creating a new one. Okay, my viewers are smart. My viewers are really smart, and they gonna do wonders in the data domain. So I trust them. So now we have this particular column and we want to use date format function, comma, date underscore format. Okay, Databricks is very friendly. It gives us the suggestions. So date format. Now we need to mention the column on which we need to apply this function. We need to apply this function on week before. Perfect. Now we need to give the format. As you can see the suggestion, it is asking a format in string format. Like, let's say we need to define the format in single quotes. Okay, I want my format, okay, Let's give dd mm y, and let's see how it converts our data. Oops, I see the error, and I think the error is I have used capital Y instead of y in lowercase. Oh, perfect. As you can see, it has successfully converted our date format from YYMMDD to DDMMYY. Let me write it here. Our initial format was YYMMDD, and now it is DDMMYY. So whenever you want to convert a data format of a date column, let's say you have a different date format and you want to convert it into a different date format, just remember this particular function. This is very handy. See you with the another PySpark function. It's time to talk about the strategies or functions or the options that we have in PySpark to handle nulls. So as you can see in the screenshot of the data frame that we have, so you must be wondering like how we can handle these null values. Let's say this one, and this one. So we know that nulls are the bread and butter of every data professional. So we get nulls and we need to treat it wisely. There are multiple ways that we can handle nulls. We can either drop nulls, we can either fill null values. We have so many options. So let's get started with handling nulls in PySpark, and we will see all the possible options that we have within PySpark so that we can work with nulls efficiently. And let's see. So here we are in our PySpark notebook. So as you can see, our data frame, and we have this column in which we need to treat nulls. I have designed a strategy in which we will see two different kind of scenarios. Like we have multiple scenarios, but basically two different kind of categories. Category one is dropping nulls, and the second one is filling nulls. So first of all, we will see this strategies or how we should drop nulls in the PySpark data frames, and then we will talk about this how we should fill the null values, because we can do anything we want with nulls. Sometimes it is better to just drop nulls, but sometimes we cannot afford dropping nulls because of the sensitive data. So we are considering this column, and let's look at the first category, that is dropping nulls. So we have a function. Okay, let me put heading, sorry. So md, and then we will say handling nulls, and within this we will create another heading that is for dropping nulls. Okay, perfect. Dropping nulls. So I will tell you all the available functions that we have to drop null values and how we should actually drop the records. The best way to do it. Simple, we have to drop all the records which have null values. Simple. So we drop the records based on the data frame level. So let's say we have this data frame df and we want to drop records. We know that we have only one column which have null, so we have two different kind of options available to drop records. Let me show you what are those. First of all, I will write df dot drop na. Simple. Drop na. Na means not available, na means null, so whatever you can say, drop na. Okay, here, yes, I was talking about this one. Here, as you can see, we have get the suggestion in which it is asking how we want to drop the null values. What does it mean? It means If we write any, that is one how. If we write any, that means if any null value is available in any column, so it will basically drop the record. It will not think of anything else. Second option, we have all. What is it? All. Okay, let me type it here. All. If we write all, then it will only drop the records which have null in all the columns. So these are two kinds of drop NA functions or options we have available. So let me first write all. So what it will do, it will drop all the columns, sorry, all the records in which we have null in all the columns. That means here we have null, here we have null, here we have null, here we have null, like the whole record is full of nulls. Then it will drop the record. Let me run this. Dot display. Okay, it has successfully dropped all those records which had null in all the columns, like this one, this one, this one, this one, this one. So all those records are deleted. We cannot see the difference because we did not have any record which had that particular row which has all the nulls in columns. Now you will see the difference. Now our second function is any within drop any. So when I write any, df dot drop na and how equals to any, this time it will drop all those records if they have null in any column. So let me show you the result. So let's see, here we have null, so it will drop this particular record. Okay, then we have null here, it will record this, it will delete this record, it will delete this record, it will delete this record. So it will basically check null in any column, and if it sees null, it will drop that record. It is so simple. So let me run this command to show you the result. See, now we cannot see any data, any record with null in any column. So this is very sensitive to use because you will lose data for all those columns in which we have nulls. So just use it cautiously. The best way to use it, the third option, that is subset. That is my favorite because in this we can, you can say, tell them, you can additionally put that parameter that you want to drop nulls, but subset is this one, simple. So in our case, we need to drop all those records in which we have nulls in only this particular column, in this particular column. So here we will add this column in subset. Okay, so now we will run drop command once again using subset. df.drop_na. Okay, now I will say subset. Subset equals to, and I think it was order type, the column name, order type dot display. So now what I am exactly doing, I am saying, hey bro, please drop all those records, all those null records, but check the null values only this particular column. That's it. If you encounter any null value in any other column, just forget. You just need to focus on this particular column. So this is so easy and so handy when you want to make sure that you do not want to lose data. So this is your go-to option. Now I want to just run this. What? Okay, I knew it, like I have used wrong column name. Let me see the column name once again. It is outlet size. So this error is regarding the column name. It is saying that it cannot find any column name because we do not have any column name with this particular name. So now the name is outlet size. Outlet size. Is it size or something else? Let me see. Outlet size. Yeah, it is outlet size. Now it should work fine. Simple. Okay. Now you can see the difference. Now we just have 6,000 plus rows instead of 8,000 plus rows. That means it has dropped all those null values available in that particular column. See, now I cannot see any null values. So this worked well. So this was all about dropping the null values. But now I do not want to lose data. I know I have null values. Let me show you the df once again. Let me say df.display. So now I do not want to drop the records because my data is really sensitive. So now the second approach comes, we can fill the null values. So how we can fill the null values? Let me show you. So the requirement again gets divided into two parts. So one is replacing all the null values. Like if it encounters null in any column, it will remove that null and it will replace it with the value that I will provide. Okay, that is one thing. Second thing, second thing, it will only replace the null values in those columns in which I have asked Spark to do. Let me repeat. So let's say we have this column and I want to just replace the null values available in this particular column only. If it has null in any other column like this, no need to worry. So let's quickly discuss both the scenarios and let me show you the output of both the code. So now this time we are talking about filling NAs. Filling NAs or filling nulls. Okay. First scenario, replace all the null values. I do not care about any column, anything, just replace all the null values with a value that I will provide. How we can do it? We have a function called fill NA. What is it? Fill NA. Let me type it here. It's fill NA. So it is fill NA. So we will simply write df dot fill NA and we will just provide the value that we want to replace the null values with. So let's say I want to enter not available. Not available. Simple. Now I will just display the data. So now you will see it has replaced all the null values with this value that is not available. See, see. We had one null value here, and as you can see, it has replaced it with not available. We have null values available in this column. Yes, it has replaced that with not available. So this was for all the columns. But again, my personal favorite is subset. We can mention the subset of columns that we want to ask Spark to just change the values or just change the or just replace the values for these particular columns. Do not worry about any other column. So it's very simple. You just need to add subset function. So how it works, df dot fill NA, then you need to assign the value that is not available, and then we will say subset. Subset is outlet size. Simple. Let me just display the data. So now it will only replace the null values available in that particular column. That's it. See, in this particular column, it has not replaced the values. See, there's still null, but in outlet size column, it has replaced the values. that is not available, not available, not available. See, so here is the way that we work with null values. We handle the null values using drop NA, fill NA function, and on the top of it we use a subset function. Yes, so this was all about handling nulls. So let's learn another important function available in PySpark, and I hope you liked handling null session because this was very useful because we often see null values in our data frames. So this was all about nulls. So let's see the another function. Now it's time to discuss an advanced function, that is split function. Why I'm calling it as an advanced function, you will get to know very soon. So what is this function and why we use it? And what is this indexing? Calm down. Let me tell you each and everything. Let's say we have this column and we want to split this column into a list. Let's say I want to store this value as a separate value and this type 1 as my separate value. Because if you notice it, they are actually two different values that are being stored in one single column. So let's say I want to create a separate column in which I will store this type 1, type 2. So for that, we need to use split function in which we will store all the elements as a list. Then we will make use of indexing. Now, what is indexing? Let me tell you. So as you know, this is our list. And in this list, we have two elements. This is element 1. This is element 2. Let's say we want to create a new column in which we will use this type 1 value only. That means I want to use index 1 because our index starts with 0. So all those who know a little bit about Python, so they would know about indexing. Those who do not know anything, so indexing is basically we use within list or within array. So our index starts with 0. So this is our index 0. This is our index 1. So this is all about indexing and this is our split function. Now I know this is the scenario that we want to achieve and you are very excited to actually perform this using PySpark. So I do not want to let you wait. So let's discuss how we can actually achieve it in PySpark. Now it's time to actually learn how we can use split function. It is very easy and very interesting because you will be storing different values as a list and then you will fetch the value using indexing. Do not feel overwhelmed by this information because this is really simple because you have me to simplify each and every concept so that you can confidently sit in the interviews and you can confidently perform all the activities necessary to transform the data. Simple. So as per the requirement, we need to work with this particular column and we will break this column into two values. First is supermarket, second is type 1, and you will be noticing that we have a different value that is grocery store. So first value is grocery, second is store. Simple. So let's learn how we can use split function. Syntax is really simple, and before that we will first mention the heading. Okay, we are using split function. Oops, split and indexing. Perfect. Perfect. So now, finally we are learning split function. Very simple. DF, that is our data frame. We need to, obviously we are transforming the column, so we will use with column and column name is outlet type. Okay, simple. Now we will write split function. Simply write split. Okay, parenthesis. Then we need to apply this function on which column? On column outlet type. Okay. Now we want to split our outlet type column on which delimiter. Now what is delimiter? Delimiter is like can be anything. So in our scenario, it is space because we have supermarket, as you can see here. Then we have space, then we have type 1. So we can define the space as our delimiter. So we will simply write double quote and enter space. Simple. Let me zoom it for you guys. Split, column name, and then the delimiter. Simple. That's it. So this will convert our all the values as a list. Let me show you guys. Not display. Let me check. Yes, perfect. So as you can see, our column, this one, outlet type, is converted into a list. See, let me expand it. So now you can see both the values coming inside this list, coming inside this list as different entities. So we have supermarket, type 1, supermarket. So now we will make use of indexing. So let's say this is our list and I just need to fetch this value, which is this one, type 1. That is our second entity. And what is the index of this particular entity? 1. Yes, 1. Because our index starts from 0. So I will say, hey, just split these values and convert it in a list. After converting it in a list, just give me the value which is available at index 1. Let me show you how we can achieve it. So here, let me just add subheading, that is split. Okay, now we will use indexing. So I will simply copy this code. Okay, I will paste it here. Before that, let me create a subheading and I will say indexing. Perfect. Now everything will be same. Let me show you. Everything will be same. I will just add index here. Right after I am creating my list. So I will say, let me zoom it for you. So here we have outlet type. Then we will add, hey, I just want element of index 1. See, first it converted our values in a list. Then we are asking just return us the index 1. That's it. Now what it will do? It will only give us the type 1, type 2, the second entity. Let me show you. Perfect. As you can see, we are receiving only the second entity, which is of index 1. So this was all about split and indexing. So here is our next function, which is strongly related to this particular function, that is split. So are you excited for that? Let me show you that function. So here we are with a new function which is strongly aligned with split function. So this is explode. Don't worry, this won't explode your code. Yes, it can if you do not know how to use it. So this is an explode function. What is it like? Why we should use this function? So if our column is in the form of an array, or you can call it as a list, and we want to explode this column into rows, as you can see it here. That means we want each value in a new row. See, here we have tier 1 and we have two values. We do not want to aggregate the values. We want each row having a new entity. That means each row having tier 1, having supermarket, then tier 1 having type 1 as well. So we want to actually explode the list. So this is the special use case where we use explode function, and this is a special requirement that we rarely get. That doesn't mean that you should not know about this function, because this is an outlier. You should be aware of this particular function because you will outstand if you know these special functions. So let's see how we can actually use it in PySpark. Let me show you. So let me show you how we can use explode function. And before that, we need to create a data frame in which we have a list. Yes, you got it. We just have created list, but we did not save it. If you remember, we just displayed it. So now we will create a new data frame in which we will create the list and then we will explode it. And I do not want to mess my original data frame. So that's why we are creating a new data frame. So before that, first of all, let's put the heading, that is explode function, explode, simple. And for that, we will create new data frame, that is dfexp. And I have simply copied the code that we just used to create the list of the values. So I will simply display it, dfx.display. Perfect. So now it will give me the data frame in which we have a list as a column. See this one. Now, as per the requirement, I want to explode this column. So we have just discussed that we want each value in a different row. That means in one value we will see supermarket, and in the next row every column will be same. We just have different value, that is this one, type 1. So it will explode the list into rows. That's why it is called explode. So this is an advanced function because it works with array. So this is the one that you should know before sitting in your interviews, because this is the outlier. Like, not everyone will know this function. So let's see how we can do it. So simply we need to say dfexp dot select, or we can say with column, because we can just transform the column, it doesn't matter. So the column name is outlet type. Okay, now we will write explode. What we will write? Explode. Explode. Then we need to mention the column which we want to explode, that is outlet type. Simple. Yes, it is that simple. Now we can display it. Before running this command, you should imagine the data. You should see the values exploding in different rows. Let me just show you. So now you will see perfect, perfect, perfect. See, I knew it. Now you can see that our list is exploded into rows, and now we have a new row for every new entity. See, so this function is used when we want to break the list. That's it. So this is a very special requirement that we get, but you should be aware of how we can efficiently use this function. So I hope you like this function as well. And yes, this is an advanced function. So let's learn a new function in PySpark. Another powerful function available in PySpark, and the function is none other than array contains. What is this function and why we have this function? So this function is strongly aligned with split function. Why? Because we work with array columns with the help of this function. What I am saying, let me explain. So as you can see that we were working with this column which had a list, or you can also call it as 1D array, that is one dimensional array. So let's say we have this column and we want to know if type 1 slash supermarket is available in this particular column. Let me tell you what exactly I'm talking about. So let's say I want to know is type 1 available in this particular list. How we can check? Because this particular column is an array. It's not just a common string column. So how we can work with this particular scenario? We will use this powerful function that is array contains, which help us to compare the values within the list or 1D array. Let me jump directly to the notebook and show you how exactly we can work with this particular function that is array contains. Let's see. So now it's time to actually use array contains function, and for that we will use our df underscore exp data frame, because in that particular data frame we have created a list of column. So let me quickly display that data frame. Let me look at that column. Perfect. So now I want to create a flag in which I will put the condition if we have, let me type it here, type 1 in my outlet type column, then return yes, otherwise otherwise return no if it does not contain. So it's the basic requirement, but it requires some work to implement it. Let me show you how we can create that particular column. So first of all, we will write here df dot with column, because we are going to create a new column. I will call it as type 1 flag. Then I will use this function that is array contains. So I will simply write array contains. So I can choose my function from the list. Array contains. Now, as I always say, just keep an eye on the suggestion, because it will definitely help you to obviously get to know the syntax plus the parameters that you want to pass. So first of all, it is saying that we need to pass the column name on which we need to apply this function. Then we need to give the string that we are finding in this particular column. So first of all, we will mention the column, which is outlet type. Then we need to define what we are exactly looking for inside this column. We are looking for type 1. Simple, simple, simple. So now we will say dot display, and now let's see what it will return. I'm expecting, oh, due to a data type mismatch. Hmm. Oh, I got it. I just made a silly mistake. Instead of using df underscore exp, I have used df, and in df we do not have any list. So it's good to encounter with errors, because that's how you learn and grow. Okay, let me read on it. Okay, I'm expecting a boolean value, because this will tell us if the condition is true or false. That's the main purpose of a flag. Gotcha, gotcha, gotcha. As you can see, we have created one flag. So it is saying true for all those values in which we have type 1. If we do not have type 1 available in that list, it is returning false. As you can see, true and false. As you can see, here we have type 1 in the first record, and we have type 2. That means we do not have any type 1 in the second record. So it is very handy, and it is very useful when you want to create flags. And obviously these types of questions come to your interviews very often, so be prepared. So now we have gained a good level of understanding working with array columns. So it was a big deal to learn all these scenarios, functions, whatever you want to say. But now you know each and everything. So if you encounter any question, any kind of scenario, any kind of requirement in your daily job, just perform it efficiently. So now it's time to learn another function in PySpark. Let's learn. Now it's time to uncover the most popular function in the world of data, that is group by. We cannot imagine data transformation, data processing without this buddy. Group by, group by, group by. We have used this function very often while dealing with SQL queries or using pandas library or using anything within the data world. Group by is our go-to function whenever we want to aggregate our data. So finally, it's time to learn this powerful function, and we will be covering many scenarios under this powerful function because this is your go-to function for all the aggregation tasks. Just to give you an overview how actually we perform group by behind the scenes, so let me tell you how actually it will work. So let's say we want to apply group by on this column. Okay, sorted. And we want to find the sum of this column. Okay, sorted. And we know how to perform it in SQL or in Python, in pandas. Let me give you an overview how actually it will be performed behind the scenes. Okay. Let's suppose we have multiple values for snack foods, as you can see. So we have two snack foods, one, two. So when I will tell Spark to group by on this column and find sum of this particular column, so what it will do, it will take these two values, and for now I'm just talking about snack foods. So there's one value for snack foods. Okay, there is another value for snack foods. Here we have 57. Just ignore my special drawing, 57. And here we have 107. Okay, so what group by will do, it will treat all these values as one. So it will become this, in which we have just one snack foods value. Then you will say, okay, this will be treated as one record, but these are actually two records. Yes. So here is the power of aggregation. So we are saying just add this value and this value and give me the final output. So these two values will get summed up and will return only one record. That's how it performs group by behind the scene. So all these values will be collapsed into one. Then all the subsidiary values of another column on which we are applying aggregation will be collapsed as one value. This is the, you can say, behind the scenes that we get whenever we use group by function. So let's practically write the code and cover multiple scenarios, because I want to cover at least 3 to 4 to 5 scenarios, so that you will get to know each and everything regarding this handy function, that is group by. So let's see. So we are here in our Databricks notebook. So as per the ritual, we will first mention the heading, that is group by. Okay, and as I just mentioned that we will be covering multiple scenarios. So first of all, let's discuss the scenario one. scenario 1. What is the scenario 1? Okay, let me show you. First of all, let's display the data. Let's display the data frame. So the scenario is, we have this particular column, item type. I want to find the sum of MRP for each item type. That means I want to find the total MRP for dairy. I want to find the total MRP for soft drinks. I want to find the total MRP for like all the values, all the values. So let's see how we can do it. So what is the real-time scenario? So let's say we want to find the sales for each item type. So this way we can actually find the sales that we have got in each item type. So it is our scenario 1. So how we can do it? Here is your buddy will tell you how you can do it. Don't worry. First of all, write your DF. That is the first thing. Then we will use group by. Okay. Then let me zoom it. Then in group by, we need to mention on which column we need to apply group by. So we need to group our item types. Okay. So we will here write item type. Simple. Now our data frame is grouped. So as we just talked about that our all the values are stacked. Now we need to use an aggregation function so that all the associated values in the next column, which is MRP, will get add on. So here, as you can see, we have so far we have grouped all these values. Now we need to sum all the values available in this column. So what now we will do? We will add an aggregation function. And how we can add aggregation function? Just add dot agg. Agg stands for aggregation. Then what exactly we need to perform as an aggregation? It can be either count or sum or average, any aggregation function. But in our scenario 1, we need to find the sum. So we will write sum of which column? Item MRP. Simple. This is the syntax. Simple. You are good to run this. Okay, let me run it for you guys. Don't need to worry. Let's look at the output. Perfect. So as you can see, we are getting distinct values here. That means our data is grouped, and we are getting the aggregated value here. So it has just applied a sum on all the records. So this was very simple. Let's discuss the scenario 2, and this scenario is for you guys that you will be doing. So I will not tell you how you need to do. Scenario is, instead of finding sum, you need to find the average MRP, because in this scenario I want to know the average MRP that we have under each item type. So this task is for you, and I give you just 10 seconds to write the code. Okay, time up. I know you have written down the code. So just to confirm, I am writing the code for you. So let's write first of all scenario 2. Okay, and as I just mentioned that we need to find the average. Okay, so df dot group by, and now we will write our column on which we need to apply group by, that is item type. Then we need to apply AGG. This time instead of sum we will write average. Average or ABG, I'm not sure, it's ABG. Yeah, you can just try. So ABG, then we will write our column, that is item MRP. Simple. And now we will see the average price, average MRP of each item type. Perfect. 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 This is our column on which we have applied group by, and this is our average. Now let's level up. Now instead of applying group by only on one column, I want to apply group by on two columns. That is my scenario 3, because this time we are leveling up the game. So the scenario is, I want to find the sum of item type, okay, and obviously we will aggregate on this column to find the sum of each item type. Along with this, I want to apply group by on this column as well. So how it will work, let me tell you. So first of all, I want to apply group by on this, that is item type. So within item type equals to dairy, we can have multiple outlet size, medium, high, low, all the values, right? So it will tell me the sum of this column, which is this one, item MRP, under dairy equals to outlet size medium, dairy outlet size high, dairy outlet size small. Similarly for all the item types. So this is the scenario 3, and how we can apply group by on two columns, let me tell you. It's very simple. And why it is simple? Because now you have found this YouTube channel that tells you each and everything from scratch. So let me tell you how you can achieve it. So let me write scenario 3. Oops. Scenario 3, yeah. So here we will write df dot group by. Now you just need to mention both the columns, and as we have mentioned that we will first apply group by on item type, so we will write that column first. Here the order of columns matters. Item type, then it will consider outlet size. Okay, outlet size. Perfect. Now we need to apply aggregation on item MRP column. So we will say dot agg sum of item MRP, and this time I also want to use alias because I am not into using that messy column name. So here I will use dot alias and I will call it as total MRP. Simple. So let's display the result. Are you excited? Let me run this. Perfect. As you can see, we have item type here, and then we have outlet size here, and then we have aggregation on this. So now as you can see, we have one value here and it is talking about medium, and then it is finding the aggregation. Then we have same value here, then it is talking about high, then it is talking about the total of this value on outlet size equals to high, and then it is aggregating the value. So in this scenario we are using group by on two columns. Let's try one more scenario. Do you want to try? Let's try one more, bro. Okay, so now it's time to use scenario 4 or create scenario 4. Let's create it. So let me level up. So I want aggregation on these two columns, but along with total MRP, I also want to know the average MRP. Yes, I want to apply both the aggregation in one transformation. Let's do it. So I hope you all are aware of the scenario. So we are going to apply group by. Let me show you. we are going to apply group by on this column, on this column, and then we will find sum of MRP, and at the same time we will find the average of MRP. Let's do it. Let's do it. This is our scenario 4. See, I just want to educate you guys, so that's why I'm covering all these scenarios, because I know the more you practice, the more proficient you will become. So let's try this one. Scenario 4. Okay. So now I want to use group by on both the columns, that is item type, and second one was outlet size. Okay. Then I want to use AGG. So how we will do it this time? First of all, just write your first transformation, that is sum of item MRP. Perfect. Now just add a comma, because this is our second aggregation. We will write AVG and then item MRP. Simple. Now just display. So this time, let me zoom it. So this time you have used 2 aggregation and 2 columns as well. Level up, level up, level up. Okay, let me run this. Perfect. So here, as you can see, that this is our first aggregation, or you can say first group by, second group by, then we have our aggregated column, that is sum, and along with sum we have average. So this was all about aggregation, this was all about group by. Now I have one special function that falls under the umbrella of group by. Do you want to learn that function? Let me show you. So here we are with another function, which is collect list. Wow, I haven't heard about this function. I also felt the same when I got to know about this past month. In the past, I think, yeah, in the past month, yeah, like in the month of, I think, August. So this function was quite new to me as well. Then I got to know that this function is a replacement or is an alternative to the function called group concat available in MySQL. What is it and how does it work? Let me tell you. So let's suppose we have this data frame in which we have information for users, that user 1, user 1, okay, user 1 has read book 1, user 1 has also read book 2, okay, user 2 has read book 2, user 2 has read book 4. So all these informations are there. Then now we want to group by on users, okay, that we know how to apply it. This time, instead of finding count, sum, average of number of books, no, we are leveling up the game. Instead of finding the numbers, this time we will store each and every entity in a list. So that's why this is the desired output that we want. We want to group on every user, and then we want to create a list that will hold all the values associated with that particular user. So how we can do it? Let me show you in just few seconds. So now let's see this particular function, that is collect list. How we can actually perform this? So for that I have prepared one data frame for you all. So you can just copy paste this code, and this is our data frame that has just 2 columns, user and book, in which you can see user 1, book 1, book 2, user 2, book 2, book 4, user 3, book 1. So as we just mentioned that this time, instead of finding count, sum, average, no, we are leveling up the game. We want to aggregate all the values. Instead of count, sum, average, no, we want to use all the values, and we want to put all the values inside the list, so that we will get to know, okay, user 1 has read book 1 and book 2 both, User 2 has read book 2 and book 4. User 3 has read book 1 only. So this way we will store all the values inside the list. How we can do it? Let me show you. That's where we have a function called collect list, and this is a function which is very similar to group concat, which is available in MySQL. So if you are very familiar with MySQL, you must have used the similar function which is named as group concat in MySQL. But if you are not familiar, do not worry, because now we are aware of this function in PySpark. So no worries at all, bro. So how we can use it, let me show you. It is very much similar to the aggregation function. So the code is similar. We will write df book.group by. As we all know that we want to group our users, so I will simply write user, and then we will perform agg, and this time instead of finding sum, count, average, max, min, now we want to group all the values. We want to aggregate all the values. So how we can do it? We will simply write collect list, and within this we need to mention the column. Simple. All set. So I will now simply write display. So now you will see the number of books, yes, with their names in an aggregated data frame. Yes. This is the function that I also got to know about in just, I think, in the past few months. So that is the new addition to my knowledge as well. So I thought, why not to share it with my data lovers? So here I am sharing this particular function with you all. So now if you want to group your values and you want to aggregate all the items within that, so just use this function. This is your new go-to tool if you are looking for an alternative for group concat in MySQL. So this was all about the collect list. Let's look at the another function available in PySpark. So all the Excel lovers gonna love this particular section. So this section is all about pivot, pivot, pivot. Being a data professional, we must have used this function in Excel where we apply pivot very often, but we are working with big data. So we cannot apply pivot in Excel while working with big data. No worries. PySpark allows us to use pivot within the Databricks notebooks. So that is awesome. So as you all are aware of the pivot function, but still let me give you an overview. How does it work and how it will look like? Let's see. We have this particular data frame. Okay. So we want to create something like this in which we will add here the item type, that is dairy, soft drinks, fruits and vegetables, all the things. Then at the same time we will add another layer of the entities, that is medium, high, and null, or like all the values of outlet size, like maybe small. Then it will map on both the values, and then it will perform an aggregation here, like this, like this, like this. And this aggregation can be anything: sum, count, average, anything. It can handle everything that Excel handles. So I'm very excited to construct this one, and I know all of you are excited as well, because this is very powerful thing when you work with, you can say, if you want to analyze something, you can do it in Databricks as well. So no need to download the CSV and uploaded it on the Excel and then apply the pivot. No, bro, we have PySpark, and being a PySpark developer, we can apply pivot like this. Let me tell you how you can do it in PySpark notebook. Let's see. So here we are in the Databricks notebook. First and foremost thing, let's create a heading. Okay, this is for pivot. Okay, so as we have already discussed this scenario, so I can still show you again. So this is our data frame, and we gonna put these values in our rows, these values in our columns, and these will be our aggregated values. Let's create the pivot. Okay, very simple code. Let me tell you, just follow me. df dot group by, yes, you heard it right. We will use group by here because we want to apply group by on all those values which will be coming in the rows. So in our case, we have item type that will be coming in our rows. So we will simply write group by, and then we will need to write item type, simple. Then here is your favorite function. Yes, dot pivot. Here we need to mention the column in which we need to just use the entities in the columns. So here we will write outlet size. Oops. Then aggregation. What we need to apply? Let's say we want to sum our item MRP, or let's say we want to find the average of MRP. Okay, let's find average of item MRP. Simple. Simple, simple, simple. Now we just need to run this code. So are you excited to see the pivot? I'm very excited. Let me show you as well. Okay, here we go. Okay, so this is our pivot, and just tell me in the comment section, uh, do you get the vibe of Excel? Just kidding. So as we promised that we will put these values in the rows and these values in our column, you can see null because we have null in that particular column as well. So high, medium, and small, and these values is our average values. Perfect. These are the average. And how you want to interpret is, let's say I want to know the average MRP for outlet size equals to high and item type equals to hard drinks. So this is the way we should interpret the pivot. I know you like this particular transformation a lot, and yes, I also have used this particular transformation multiple times whenever I want to analyze my data. So this is my go-to tool, and I know this will be your go-to tool as well from now. So let's learn another powerful function in PySpark. Now it's time to discuss the much awaited function, that is when otherwise. I was waiting since so long to discuss this function, but I was just waiting for the right moment, and I think this is the right moment to discuss this function because this is my one of the favorite functions, because I have used the similar function in SQL a lot. And what is that function? Just guess it, just comment it down. The function is case when statement. That is my favorite function in SQL. So obviously it will be my favorite function in PySpark as well. So what this function does, like how it works, let's discuss. So let's suppose we have this data frame and we want to create flags, columns that are based on the conditions. Let's say condition number one can be if item type is either dairy or soft drinks, then write drinks, like any condition, any condition. If you want to create conditional columns, just use this function, that is when otherwise. I have used this function in PySpark a lot, and as I have already mentioned that I have used a similar function in SQL, that is case when statement, a lot. So this is my favorite function, and this is little bit tricky, but do not worry, I will tell you each and everything from scratch how you can use this, and we will cover 3 to 4 to 5 scenarios just to master this function. So just be with me for a few more minutes and you will master this function. Let's see. So here we are in our Databricks notebook, and this is our data frame. So as we have just mentioned that we will be covering multiple scenarios to master this particular data. function. So let's start with the basic and very simple scenario. So I want to create a conditional column which will say veg or non-veg. Okay. So if any value inside this column, that is item type, contains this value, then it will consider it as non-veg, otherwise it is veg. So it is similar to if else statement in Excel, it is similar to case when statement in SQL, and we have here the when otherwise statement. So let's create this conditional column and let's see how we can do it. Obviously, first of all, we need to put heading, that is when otherwise. Okay, so now here I will create a new column, so that's why I'm using df.with column. I will say veg flag. Okay, then here we need to write the function. First of all, we need to write when. Okay, uh, parenthesis, because we will write our condition within this parenthesis. When column item type equals to then we want our value non-veg. Oops, right? So let me zoom it for you. As you can also see, when, then column, then condition, and then if it is true, the value. If that condition is false, then we will write dot otherwise, as it is very simple and it is very understood. In otherwise, we will say veg. Simple and sorted. Let me run this and let's see, we get the desired output. That ran fine. Let me check. Perfect. As we can see, this new flag column in which we have this value as non-veg as expected. So let me give you an overview again what we have just did. So first of all, we mentioned our column name, then we write when, and within when we write the condition. Condition is column and then equals to that value, then comma means the true value. If that condition is true, what it should return? It should return non-veg. If it is false, it will take the value which is provided under the otherwise function. It is simple, I know, and it is very handy, and we are covering more and more scenarios right now, so just be with me. So our first scenario is done. Let me write here scenario 1. Scenario 1. And now I will level up the game because I want my data community to be efficient with all the function and with all the scenarios. So now the second scenario will be what we want. We want, let me think. Okay, I got it. If my item type is veg, that is my first condition, and item MRP is more than 100, then it will create a flag that is called veg expensive, and we will say yes, it is we will just mark it as veg expensive true, and if it does not, then we will say veg inexpensive, and otherwise it is non-veg. Did you get my scenario? Let me explain you again, no worries. So first of all, we will create obviously the new column, that is flag, in which we will identify if the item type is veg, that is first condition, and the item MRP is less than 100. then that particular column which will be appearing, let's say here, just imagine that this is a column. Let me shade it. Okay, so this is our flag. So that value will be considered as wedge and inexpensive because that is cheaper than $100. Then the second condition, if that item type is wedge and it is more than 100, then it will be wedge expensive. And if it is not wedge, we will simply say non-wedge. So that is a new scenario, and I am also excited to write the code for it because I need to plan it. Let's see. Let's do it. Let's do it. It's fun. Okay. It's fun. So let me quickly save this into our DF so that we can use this flag, that is wedge flag. And let me show you the data frame now. So here we want to use two columns. One is the MRP column and second one is this flag that we have just created. This one, wedge non-wedge. So we will work on these two columns. One is if the item is wedge and it is under $100, then it will create a new flag that is wedge inexpensive. If it is over 100, then it will create wedge expensive, otherwise non-wedge. I'm very excited to write the code. Okay, let's see how we can achieve it. Simple df.with column. I will create a new flag column that is wedge exp flag. Just don't mind my naming conventions. You can use your own conventions. So df.with column, that is our column name. Now we want to use when statement. When wedge flag equals to wedge. Simple. This is condition 1. How we will put the second condition? Simply using ampersand. And obviously when we use ampersand, we encode our condition into parentheses like this. This is our condition 1. Here I will write parentheses. Then condition 2. Condition 2 is wedge. Okay. Oh yeah, perfect. So this is my condition 1. Let me show you. Perfect. And our condition 2 is, here I just need to mention column because that is a condition and we need to use column object. Column. Then we will write item MRP less than 100. Then what we want to say? We want to say wedge inexpensive if both the conditions are true. This one. Oops. Yeah. This one and this one. If both the conditions are true, we will say wedge inexpensive. That means food is wedge and it is cheap. This is our first braces. This is our second braces. Perfect. So here we will put another braces here. The reason is now we want to write our true value because in our when condition, this whole works as the conditional area where we put all the conditions 1, 2, 3, 4, 5, all the conditions. Then we write if all the conditions are true, what we need to display? We need to display wedge inexpensive. Perfect. Let's do it. So this is our braces 2 and this is our braces, and then we need to write wedge inexpensive. Perfect. Now we will write another when condition. And how we can write another when condition? This is the tricky part. It is very easy. Let me show you how you can do it. First of all, as you can see, I do not have much space, so I'm going to the next line. And how we can go to the next line, we have already talked about before. Just enter backslash, the slash which is above the enter key. So I will then enter, and now I'm in the next line, but still I'm in the continuation to that code. Then again I will write dot when. Yes, this is the tricky part. Here you need to again write dot when. Then we will again write the condition, and the condition, as you can see Here I'm also getting suggestion that we need to write condition within when. So I will just simply copy this condition. So here we have copied the condition, as you can see, and here we just need to make a greater than sign instead of less than sign, and we want to type expensive because that means it is expensive. Yes. So here we are good. So we have successfully used two when conditions. One is this one. Second one is this one. Veg expensive, and now we want to finally write our dot otherwise. Otherwise, we just need to mention non-veg. Non-veg. Are you excited to run this? I'm very excited. And if we face any errors, we will just correct it. Don't worry. Boom. Okay. Unexpected end of EOF while parsing. Okay. Okay. I was so sure about this. I think I have messed up with one braces, I guess. Let me check number of braces. Oh, I got it. One brace is missing. No problem. Simple dimple. So when you work with this tricky part, when you have so many parentheses, it is very common to miss one parenthesis. Do not need to worry. Just check the code and add the missing parenthesis. No need to worry at all, bro. So here I'm very excited to just check my column, how it looks like. Perfect, perfect, perfect. Yes, as we can see that we have created the flag which says veg expensive, veg inexpensive, and non-veg. This was a tricky part. This was a tricky scenario. If you haven't got the 100% of it, just rewatch this particular session because I know this was tricky, and just come back after watching it again and let's see another powerful function available in PySpark. So now it's time to talk about joins, and yes, this is going to be a detailed session because this is very important when you perform day-to-day activities as a data engineer, plus if you sit for the interviews. Joins is a very important topic. What I have decided, so I am planning to explain each and everything from scratch. If you already are familiar with all the types of joins, that is inner join, left join, right join, full join, anti join, then it is good. It will be a good revision for you. If you are not, do not need to worry because we will be covering each and everything from scratch. Because it happens with us, like we perform joins, but we actually do not know how the architecture works behind the scenes. So it will be a good understanding for you all. Plus, as you can see, I have marked anti-join with red because this is a special topic for this session because anti-join is a new concept and it is not readily available in all the languages. It is not even available in SQL. Yes, we have some workarounds using subqueries. We can apply anti-join, but we do not have a keyword that we can use in SQL. So this session gonna be very detailed and very informative. Just be with me. Let's start with joins. So let's understand the concept of joins with our first type of join, which is inner join. So what is the inner join? Why we use it? How it performs behind the scenes? Everything we gonna cover from scratch. Because sometimes we do use different joins, but actually we get confused when we actually look at the architecture. So this is a good time to revise all those basic concepts. And if you are new, then it will be very beneficial for you. So let's see how it actually performs inner join. So as you can see, we have two data frames. This red one is our df1, and this blue one is our df2. Oops. Simple. So now just forget about inner join, left join, any join. If we want to join two data frames, just use your common sense what we actually need. Yes, joining key or joining column, so that we can compare the values and we can actually apply the join. So in this scenario, we have joining key as department ID. Yes, this column. So this is the joining key. Joining key is basically, you can say, a key or a column that is used to join two different data frames or two tables. So when I say I want to apply an inner join, what actually happens? Tell me. So inner join means we want to just output the values which are common in both the tables or both the data frames. Let me show you what do I mean. So let's say we have this data frame, and we want to apply inner join. That means I want to show which records are common in both the data frames. And which is the joining key? This one. So when I write the code for inner join, so this will execute the code like this. So what it will do? It will take the first value of our joining column, this one, D01. It will look for this value in the data frame 2 and it will find the value. It will say, hey, I have this value. Woohoo! That means it will map the values because that is common in both the data frames. Same thing happens with D02 because we have D02 here. Simply it will map it. Now here comes the tricky part. Here, as you can see, we have two values for D03. We have only one value here. What gonna happen? Nothing. Just go with the fundamentals. It will take the third value, that is D03. It will look in this data frame. It will find, it will simply map it. Simple. Then again, it will go for the fourth value. It will look this value in this one and it will find this value here. So it will map it here. Oops. It will map it. Why you are going to do D04, bro? You want to apply join here. So now it will create two records for D03 because we have two records of D03 in one of the tables. Simple. Now, second tricky thing. What gonna happen with this one? With D04? Nothing. Because this record is not common in both the tables. So this record will not get counted. Simple. This is the inner join. Next thing, D05. Do we have D05 in both the data frames? Yes. So this will also get mapped. This is the architecture of inner join. This is the concept behind inner join. Why do we need, how do we need, and what exactly it returns. So this was all about inner join. I know you all are very excited to look at the code. Let me show you how you can actually perform inner join in PySpark. So we are here in our notebook. So just to let you understand joins, I have created two data frames. As you can see, this is our joins topic and this is our code for data frame 1 and this is for data frame 2. Simple. And you know that you do not need to worry. You can just copy this code using my notebook or you can just copy it from my screen. It just takes 2 minutes. So let me just show you the data frame. This is our data frame 1. This one. Yep. This is our data frame 1 as we just saw in the slides. And this is our data frame 2. This one. Now we know the architecture. Now we are excited to look at the code. Okay, let me show you. It is very simple and code will be similar for all the join types, but it is very important to actually know the structures. Reason number one, interviewer will not ask you to provide me the code, like how to apply the left join. No, it will give you two tables and it will say just tell me the output of like left join, right join, inner join, anti join. And at that time, if you are aware of the architecture, if you are aware of the concept, how it actually applies the joins, then you can confidently give the answer to that question. So that's why I am focusing more in this area. So do not need to worry. I'm going to tell you each and everything. So let me quickly write the code for left join. Left join. Oh, sorry, inner join. My bad. Because left join is very popular. So that's why it came into my mind whenever I talk about join. And you will get to know why it is very popular. Inner join. So here we need to apply inner join. What is the code? It is very simple. df1 dot join, with which data frame we need to apply join? Right, df2. Sorted. Then add a comma. Then we need to give the condition. Here, as you can say, it is giving us the suggestion, right? So we need to apply the join using a condition, and condition is department ID. Simple. And how we can use department ID? Let me show you. First, you need to write df1, then you will add square brackets to mention, to specify the column. The reason behind this is, again, this is an interview question, let me tell you. So first I will write department ID equals to df2 of department ID. So why do we write this? Why this one? Why do we use data frame and then square bracket? Reason is, as you can see, column name, this one, and column name, this one, is same. Spark will face the error of ambiguity, like which data frame, which column. So we have to specify bro department ID column of df1, department ID column of df2. So this is a good practice if you have same column names. So always try to provide the reference with data frame. So this was the answer to that interview question. So now you know. Then the last thing, the last parameter, we need to tell which kind of join we need to apply. We want to apply inner join. We will simply write inner. Simple, sorted. This is it. I know this is just one liner code, but the back, the behind the scenes are important. Dot display. Let me just display it. Perfect. As you can see, we got five records. This one D01, as we discussed in the slides, D02, D03 two times, and D05. There is no D04 here. So this is it. This is all about inner join. And now let's talk about left join, one of the most popular joins. Let's see. Now it's time to look at the left join. It is very popular join because most of the times we use this join. Let me tell you what is the reason. As the name suggests, left join, that means we are prioritizing left data frame. Okay, let me show you. So this is our data frame 1, which is on the left hand side. So we call it as left data frame. I'm just kidding. So basically you have to keep one data frame on the left hand side. So you have to imagine. So if it is on the left hand side, it is good to imagine. So this is our left data frame. So let me write here df1. This is our right data frame and we will call it as df2. Simple. As I just mentioned that we will prioritize left table. left data frame. What does it mean? Okay, we want to apply left join. Okay, joining key is same, which is this one, department ID. Okay, now we want to prioritize this data frame. What do I mean by prioritize? We do not want to lose our data from this data frame. This is the most important data frame. Let's say this. Because in the inner join, we can lose data. We just saw that it will only give the common records. As you can see, this D06, this D06 is not available in this data frame. So it will not give that data, but I cannot lose my data. That's where left join comes into the picture. What it will do? It will say, hey, before applying join, let me tell you, do not delete any record. Let me say it again. Do not delete any record from left data frame. So what it will do? It will say, okay, let's apply the join. Let's apply the inner join and then keep all the remaining values in the left table. Simple. What did I say? Let me show you. So first, as we all know, D01 will get mapped with D01. Okay, let me quickly map it. Then D02 will get mapped with D02. Okay, D03 two times will get mapped to D03. Okay, now D05 will get mapped to D05. Okay, now inner join is applied. Done. But what did we mention in the beginning? We do not want to delete our data. After applying the inner join, it will as it is mention the remaining data, which is this one. So it will say, hey, your inner join is applied. Now this is your inner join and this is the remaining value. So it will also show this value as well. This is our left join. Understood? I know now you are saying, hey, we understood. Let me show the code now then. Let's see how we can actually perform this in PySpark. So as we just mentioned in the slides as well, I have added this additional row so that you can feel the left join. Just to make you feel, I have added this record. Okay, let's see left join. First of all, we will add the heading. Oops, I didn't mention anything. So I want to write left join, and trust me, it's gonna become your favorite join as well, because this is very handy when you do not want to lose data. So okay, so left join, similar code. As it is similar, let me show you again. df1, which is our left join, which is our left data frame. I told you that you need to imagine. So this is our left data frame. So left data frame, we will write it first. df1 dot join. Then our right data frame, df2. Joining condition, df1 of department ID, df2 of department ID. Perfect. Now, this is the only thing that we need to change. We want to apply left join. So we will simply write left. Right, W-R-I-T-E. We will write left. Perfect. Simple. Dot display. So let's see the results. Perfect. Let's understand the output, because now you can feel better because now you know the architecture. This, okay. This is okay. This is okay. This is okay. This is okay. Now we know that this data was not matching with the df2. So what it did? it simply gave us the record from our left table, left data frame, and then mentioned null for the columns that are available in the right data frame, because this value was not available in the right data frame. So now you know the working of left join. It is as simple as that. So now if you want to apply a select statement, you can. On top of this, whatever column you want, you can. So this was all about left join. And let me tell you what is right join. Right join is simply opposite of left join. So let me show you how you can perform right join. So now it's time to look at the right join, and yes, it is just opposite to the left join. But still, we need to look at the architecture, not in detail, but we'll just give you an overview how things are working behind the scenes. Yes, I just changed my background. How is it looking now? I think it's good. So let me show you what's going on. This is our left join. Oh, sorry. This is our left table, not left join. We just discussed left join, so sorry for that. So this is our right table or right data frame. Okay. And we all know that this is our joining key, that is department ID. Okay. Things are sorted so far. Now, what's gonna happen when we will be applying join? Answer is very simple. All the joining keys, like the common keys such as D0, 1, 2, 3, will be returned in the result. Plus, all the non-joining keys such as D04, D05, which are not available in left table, will also be returned, because this time this is right join. In the left join, we got the keys from the left table, but this time we will be getting keys from the right table. So this is the architecture, this is the behind the scenes that actually perform whenever we apply right join. So this is really simple, I know, and let's try to code it in PySpark notebook. Let's see. So now let's see how we can actually code in PySpark to perform right join. It is very simple, and first of all, as you all know, we will create a heading. So this time we want to say left join. Okay, perfect. And now let's see how we can do it. It's very simple. First of all, we need to write df1, that is our left table. Then we will say dot join 2, and you know that we need to put the joining key. And just to show you once again, in our scenario, the joining key is department ID, this one. So we will be using this key as our joining key. So as we know how we can use it, first we will write the data frame 1, and then we will put here department ID of department 1, df1, then equals department ID of df2. Simple. And then we just need to specify that this is a right join. Perfect. So simply we will write right. Do you want to see the result? Let me say dot display, and we should see all the matching records plus non-matching records from the right table. Okay, I got the result. Yes, we got it. As you can see, we got all the records, the matching records. These are non-matching records like D04, and then we have null for all those columns for our left table. So this was the concept behind the right join. So now it's time to look at the most popular. Yeah, it was not much popular, but nowadays it is very popular, and the name of the join is anti-join. Do not worry, you will learn it in just few seconds. Let's see. So here we are discussing anti-join. So all those who are familiar with pandas, or let's say deployer library and R, you must be familiar with this join. Because this join is not available in SQL, so I would assume that not everyone is familiar with this kind of join. Do not worry. That's why I am here discussing each and everything you can expect from this join. So what is this join and what is the use case? It's very important nowadays. So the use case is whenever we want to fetch that data from one data frame which is not available in second data frame, then we use this join, anti-join. What does it mean? Okay, let's discuss. This is our data frame 1, this is our data frame 2. So there's a requirement that I want to get the details of all those employees which are not registered maybe, or by somehow those employees are not available in this table. That is this one, department ID. So in that scenario, we will be applying anti-join. That means we want to fetch the records which are available only in data frame 1. That's it. That's why it is called anti-join. That means we want all those records which are not getting matched with the second data frame. So this type of join is very much popular nowadays because of its use case, but I don't know when we will be having this join in SQL. There are some ways by applying maybe some subqueries or CTs function, not in function to actually achieve this result in SQL, but we do not have an anti-join, like a keyword anti-join in SQL by now, but I don't know about future. But we have this join in Spark, so let's see how we can code it in PySpark. It's very simple, very simple. Let's see. So we are here in our Databricks notebook. So let's see how we can perform. And as you know me, first of all, we will just put the heading, because these headings are important, because whenever you will be referring this notebook, you will thank me. That's why I'm just putting these headings so that you can just follow along with this notebook. So we are just performing anti-join. Okay, perfect. Code is exactly same. We just need to change anti with left, right, inner. Simple. So df1 dot join, df2, then obviously the joining key as we all aware of, department ID. Okay, equals to df2 of department ID, and then here we just need to mention anti. That's it. So what it's gonna do, let me just show you once again. So this is our df1, this one, and this is our df2, this. So now we want to fetch only this record, this one, because this record is not available in df2. So I want to fetch this record, so I should expect only this record, and let's see if we are able to fetch only this record or not. Let's see. So let me just run this command by putting display at the end. Okay, we just got one row. Perfect. So as you can see that I got the details for that employee which is not available in the second data frame. So trust me, I know the coding is like very easy when we are just differentiating between left join, right join, inner join, anti-join, but do not feel confused whenever interviewer asks you maybe architecture or how the things are being done behind the scenes. So you should be aware of all these things. So these are important. So this was all about the joins available in PySpark. So next thing is really interesting. So let's see what we have next in PySpark. So now it's time to discuss one of the most important topics that we have in the data domain. It's not just about PySpark, because this topic is really crucial in all the data domains. So what do I mean? See, you must have heard terms like row number, rank, dense rank. So these all are the functions that fall under the umbrella of window functions. Window functions are really helpful, really handy whenever you perform some special operations. So we will be discussing each and everything in window functions so that you can master this area, and this will help you to tackle all the window functions related problems in all the tools and technologies. Either it is Python, R, SQL, Spark, I do not care. Fundamentals remain the same. So you will be learning each and everything in this area from scratch. Either it is coding or architecture, behind the scenes working, everything. We will be covering everything from scratch. So let's see what are the window functions. Like, why do we have window functions? So basically window functions are like special functions which perform row level calculations. Sometimes we need to perform some special row level operations which cannot be achieved through traditional coding. So that's why we have window functions in place. Some of the popular window functions are row number, rank, dense rank. Do not worry, we will be covering each and every function in detail so that you can conquer this area like this. So are you excited to actually look at these scenarios? Or not, it's not just about scenarios. Like, we will be covering first the basics and then we will jump to the scenarios. I think, yeah, it will be better. So let me first give you an overview. Why do we have row number function, which is one of the most popular window functions? So let's see how it works and where it is really handy. So let's say we have this data frame, right? So here in this data frame, we have this column, we have this column, we have this column, and suddenly I want to create a column which will give me the unique records every time. What does it mean? So I do not care about any column that we have. I just want to create a column which will create a unique number. Let's say I want 1 2 3 4 5 6 based on the number of records. So let's see how it goes. So here we have a column that is called as, let's say, row number column. So every time it will give me a unique number, like let's say 1 2 3 and so on, so on, so on. So it will be returning a unique number every time. So let me just tell you one of the very popular scenario or use case of this function is to remove duplicates. If we want to remove duplicates, we can make use of this function. How we can do it, do not worry, we'll tell you from scratch in just few minutes. So I'm just giving you an overview. Second use case is like if you want to generate a surrogate key. What is surrogate key? Do not worry, we'll discuss that too. So these are some of the famous scenarios, circumstances where we use window function, that is row number. And it's time to actually look at the code, how we can actually perform row number transformation, row number function in our Databricks notebook. Let's see. So here we are in our Databricks notebook. Okay. And here we have this heading and this row number function, and this is our df. Okay, sorted. So before jumping into the scenario, let me show you how we can actually use this function. So let's say we have this data frame, okay, and we want to generate a unique identifier for our records. So as you can see, we have so many records and I want to create a column which will say 1 2 3 4 5 6, like it will generate a unique number for all the records. How we can do it, let me show you. For that we need to first import a library called window. So first of all, let's do that from PySpark.sql.window, import window. Simple. Just run this first and then we will perform our window functions. We will simply write our code by creating a new column. So we can name it as row column. Then in the second step, as we know, whenever we create a new column, we need to first name it and then perform the function. The function is row number. Simple. So now here is the catch. Once we write the row number function, and we have just discussed that we want to create unique identifier, now we need to use a function called over. That is over. what it will do, it will tell, hey, perform row number function on top of our data frame, but what should be the order of that operation? What do I mean? If I want to generate, let's say 1, 2, 3, 4, all the unique values for our column, is there any column it should refer to generate that order? Let's say I want to generate the order, the row number based on these values, and I want to create that order based on the descending order of these values. We have to give order by clause under over function so that it can refer that thing. If we want to perform any group by, partition by, or order by, we perform all those functions under over command. So let me show you how you can do it. So first we will write over, and this we will say, hey, perform over and then order by based on any column. So in our scenario, we can say just perform order by based on this item identifier. Let's see what it returns. So first our row number function, then over, and the syntax is similar to the SQL syntax. If you are already familiar with window function in SQL, you can relate better. If you are not familiar, then it's also fine because you are learning everything from scratch, so there's no need to worry at all. So once you have written over, then we will say, hey, window dot order by, and then we need to mention the column name, which is item identifier. Let me just check. Yes, it is item identifier with I capital. Simple, simple, and we do not need to specify the order because by default it is ascending, so it's good. Display, and now see the results. Okay, this is my item identifier, and as you can see, we have some duplicates, right? We have some duplicates, but still I will see unique identifier. Let me show you. Let me show you. Perfect, perfect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So now if you want to remove duplicates using row number, it's time to discuss that scenario. But before that, we will be discussing rank and dense rank as well. Yes, it is very important to discuss them first, and then we will just look at the scenarios, some real-time scenarios. So do not worry. Now it's time to look for the window functions rank and dense rank. As the name suggests, these functions are related to ranking. Whenever we want to provide ranking to our data frame or maybe to any column, we do use these two functions. But I have a question. Why we do have two different functions? Why we do not have just one function? Your all the questions will be answered in just few seconds, and let's see what is the difference between both the functions and how we can use these functions efficiently. So let me show you an example so that you can just relate with the output of the function. Let's see. Okay, so this is our data frame. Okay, so now if we perform rank function, what output we should get, and when we perform dense rank, what output we should get. Let me show you. So let me just draw a column here. Let's say I want to perform ranking on this column, and I want to rank this column in ascending order, and I want to use rank function first instead of dense rank. Let's see what will be the output when we use rank function. Okay, so first of all, let me just type here rank. Okay, so now as I just mentioned that we want to rank it in ascending order, so the output will be, let's say here 1. So what will be the output for the second record? Obviously 1, because we are calculating the rank. Rank will be same for the similar values. Makes sense, right? This is not a row number function which will return the unique value in every record. No, this is a rank function which will just rank the data. So this value is also 1, this is also 1. Similarly, all the similar values are 1. But Just tell me what value it will show here. Just tell me in the comment section if you already know the answer. So the answer is 7. Why 7? Why 7? Why 7? We have learned that 2 comes after 1. Why we are writing 7? There's a reason. So here we have 6 values, 6 same values. So the next value it will assign, it will start the counting from 7 instead of 2. So this is the output that you get when you perform rank function. So here what will be the output after this? Obviously 7, because both have the same values, 24, 24. Simple. So now it's time to perform dense rank function. Let's see the output of dense rank. Okay, dense rank. Simple. So now, as usual, values are same. That means rankings are same. Okay, 1, 1, 1, 1, 1, 1. What will be the output in this record? The output will be 2. 2. The reason is dance rank doesn't bother the number of values it has assigned before. It will continue the flow of the original counting. So this is the difference between rank and dense rank function. Do not make things complicated, because things are really simple than you think. So this is the common difference that you can expect asked by the interviewers. So just keep this thing in mind, and let's see how we can perform this into the PySpark notebook, so that we can learn how to perform it using our code. So the code is really simple. Let me show you how you can do it. So the most important thing of this part was understanding the concept, like how things work for rank and dense rank. So you can just use these functions in the scenarios where you want to bother the values assigned for the similar records. So then you should just go with the rank function. But if you do not want to bother the number of values it has assigned before, you can go with dense rank function. So now it's time to look for the code in PySpark. So now it's time to actually code to return the columns, which will show us difference between rank and dense rank. How we can write the code for it? It is very simple. Let me show you. So first of all, we are creating rank function, and then we will use dense rank. Okay, simple. So let me just type tf dot with column, because we'll be creating a new column, and then I can just say rank, then oops, transformation. So this function is rank. Simple. And now you can expect what we gonna do next. We need to write over function, because whenever we are just ranking any data frame, we need to tell that which column it should refer to perform ranking. Either it is column item identifier or any other column, like any column, because we do not know the order as well. We can just define the order as well. Maybe we need to rank it on the descending order, in the descending order, instead of having the column in ascending order. So it is really important to define the order. As we just did in row number, we need to do the same in rank function as well. That makes sense, right? So just write rank dot over, and within this over function we will write our order by clause. So simple window dot order by, and in our scenario we are using item identifier. You can use any column, don't worry. Then okay, that is done, and this is ready to be displayed. Perfect. Let's run this command. Okay, so now I should see 1 1 1 1 1 1 and then 7. Perfect. As you can see, we have a rank function here in which we have 7 value as our next value, and then we have 14. Do not worry, this is not a like difference of 7 every time. It's just a coincidence that we have like 6 values and the number was 7, then we have 6 values and the number was like 14, so do not worry about that. So you know the concept now, so you can just imagine the desired output. So let me just scroll it down for you so that you will not be misguided. So see, here we have 34 and then we have 40. Simple, right? So now if you want to perform in descending order this function, if you want to perform this function in descending order, how you can do that? You can just simply tell in the order by clause that you want this function to be performed in descending order. How we can do that? Let me show you. You just need to simply add .desc function that we have learned in the order by clause, and for that you just need to add column object. As you know, whenever we want to use any function that requires dot something, we need to use column object. So here we have added column object, and then we will simply say .desc. Simple. Let me just run it. Oh, one parenthesis is missing. Which one is that? Okay, let's read on it. No worries, bro. Okay, we got it. Here now you can see that it has sorted this data in descending order, then it provided us the rankings. So it's up to you. If you want to perform rankings in descending order, you can use .desc function that we just saw how you can use it. So this was very simple. Now it's time to use dense rank function, and now instead of creating a new code, I will tell you how you can create another column using the same code, because it is really important when you need to create multiple columns in one go. Instead of creating different columns in different cells, that is not a good practice. That is not the thing that you should acquire being a good programmer. You should learn the things that does the same work in less span of time. So here, let's say now I want to create another column. So first of all, let's go to the next line. Then I will write dot with column. Simple. And then I will say dense rank. Dense rank. And here I will just write dense rank function. Dense rank. And then simple dot over. Everything is same. Just we need to write dense rank. That's it. Dot over. Then obviously window dot order by. And then we need to use column object because we will be just sorting this in descending order. Item identifier. Simple. Then .desc. Then let's display this result. Let's see what we got. Ooh, error. I was expecting this error because of so many parentheses. So unexpected exception, formatting exception, falling back to standard exception. What's that? Oh. It didn't tell us the error. Let me just check. I think it is the matter of maybe parentheses. Parentheses are good. Dot over, window dot order by, column dot identifier dot desc. Oh, simple. I knew it. It's just parentheses. Because see, there were like so many parentheses. So silly mistakes. Just ignore. Now, simple. I was expecting the exact output. So now you can see here we have 8 after 1. But here, as usual, we have 2. And now we know the reason. So this was all about rank and dense rank. And trust me, you can expect some questions related to maybe just tell the output of the data, where the interviewer can give you scenarios using rank and dense rank, or it will be related to just simply tell us the difference. What is the difference? So now you know each and everything: architecture, coding, outputs, everything. Now you are all prepared, all set to answer the questions. And if you, it's not just about answering the questions. If you already are a data engineer using PySpark, it's good to have exposure of these functions as well, because we do use these functions in SQL a lot. So it's good to like explore these functions in PySpark as well. So this was all about 10th rank and rank. So now comes another function. So now the next function is basically how I can say. Okay, let me show you. Okay, so now it's time to cover another most important function come scenario available in window functions. Window functions are incomplete without covering these scenarios, and these are not just scenarios, these are functions in itself. So as we can see on the screen, it is written cumulative sum. So as it suggests that we are going to calculate cumulative sum. Okay, and we would be aware of like what is cumulative sum. If you are not, I will just show you what does it mean. So just a kind of disclaimer, just be more focused towards this area because this is a little bit tricky and this is crucial as well. And you can say if you are performing data engineering activities in your day-to-day lifestyle, if you are preparing for interviews, then also it is really important. Just be more focused with this area and let's get started. So let's say this is our data frame, right? This is our column item type, and here we have item MRPs. Now the requirement is we want to create a column with name as, you can say, cumulative sum, right? What does it mean? So what it will do, it will first record this number and it will display it. In the second row, it will not just display 141. No, it will just keep on adding the number. So this time it will return 281.92 something, right? Then in the next go, it will add 142, which will be somewhere around 320 something. Oh, sorry, 420 something. So you can just calculate it. So this is the definition of cumulative sum when we need to add row by row. How we can do it in Spark? This is really critical. You need to understand each and every working behind the row calculation, how it gets performed behind the scenes. And to achieve this, we first need to understand how we are calculating cumulative sum using normal function. Like obviously, if we want to find sum, we can use sum function, right? But when we want to calculate sum using row calculations, we have to merge sum function with window function. So it's a kind of fusion of aggregation function, but as a window function. So do not feel overwhelmed because in just few minutes, you're gonna master this function, trust me. So what we will be doing? We will be using sum function. Okay, that's easy. But we will be making a fusion of sum function with window function. So we will say, hey, just use it with over command. Okay, so that we can just make a fusion of both the functions, aggregation function and window function. Once we have the fusion, we still need to do one thing, that is frame clause. What is it? What is it? What is it? Okay, let me explain you. Frame clausing. So when we say we need to perform sum, so it actually captures all the records. Let's see, it will capture all these records. So now what we will tell to Spark, hey Spark, listen to us. Just do first capture this record, okay? Then capture the current row, that is this one. That is this one. This is first iteration, right? This is iteration number one. Iteration are like just the number of steps. Then in the second iteration, we will say, hey Spark, just pick all the previous records which are these ones, this one, and this is your current row. Do not go beyond the current row. Do not touch this part until and unless we say so. Do not touch this part. Just be limited to this record only so far, right? Then in the next iteration, we will say, hey Spark, just pick all the previous records and keep your current row this one. So what we are doing, we are picking all the previous records and we are just performing sum till current row. Let me repeat what I just said. So what we are doing in sum function, fusion with window function. So we are saying, hey, just count all the records. Let's say this is our current row. Just read all the records which were read previously and keep your current record this one, and this box will keep on shifting towards downside because we are finding the cumulative sum based on the order by clause, which is this one. I know this is tricky. But you will find it easy when I will actually show you using PySpark. So this was just an overview. If you have grasped 10% of it, it's fine, because 90% of it you will grasp it like this using PySpark. But that 10% is really important to grasp that 90%. So we are on good side. Let's see how we can do it in PySpark. So let's see. Let me show you. Let's add one code. So here, what we will do, we will first write heading %md. We will say cumulative sum. Perfect. So now, first of all, we need to create a column, df.with column, and then we will say, hey, create a column with name CumSum. Then we will say apply sum function, because we are treating sum function as a window function using over command. Perfect. Now you are getting everything that you need. Sum function based on item MRP. Very good. Then after that, we need to perform over function, and then we will say, hey, pick item type as your order by. Window dot order by item type. Simple. Now if we write just this, let me show you what it's gonna do, because first you need to digest this part, then you will have another meal. Okay, let's run this. Okay, so let me tell you what output you can expect. You will see the MRP, total MRP based on each item type value, and it will be summed up. Let me show you. So as you can see, CumSum column as 8194, 8194, 8194 in all the columns. See, in all the records, not in all the records. Let me tell you what is the reason. So what it has done. So as you can see, we have records still here. Let me scroll it down more. Okay, till here. There's a reason behind it, because we have value as soft drink till here, or baking goods, like any singular value. So what it has done, it has calculated item MRP, this one, all the item MRP. It didn't show us the cumulative sum, like it didn't show us like hey, add 147, then add 181, then add 93. What it has done? It has added everything. It has added 147, 81, 93, and so on till 108, and then it showed a single value. But what was our requirement? What was our requirement? Our requirement was to show cumulative sum. We want to stop Spark in every record. Like in first iteration, like in this iteration, it should show 147. In second iteration, it should show 147 plus 181. That's it. That's it. Stop. Then in next record, it should show 147, 181 plus 93. Stop. So how we can stop Spark? Let me show you. It's funny, but once you grasp this concept, you gonna be an outlier in the crowd. Trust me. So how we can do it? It's very simple. First of all, let me just copy that code instead of just rewriting it. So now we will be adding frame clause. We will be changing frame clause. How we can change frame clause? Let me show you. That's why I'm here. Don't worry. So now what we will do, inside the over function, let me zoom it. Inside the over function, just remember, we need to change frame clause inside the over function. Every recipe will be cooked inside over. Just remember this. Inside the over function, and over function has this braces, we need to enter this. Now we will write rows between. Let me repeat what we will write: rows between. Simply write dot rows between. What it will do? It will tell, hey, just keep the rows between previous values till current row. Till current row. Stop at the current row. That's it. And then we need to just give the range. So as we just mentioned, we want to tell Spark that you can just pick all the previous records. How we can tell it? Just write window dot unbounded preceding. What does it mean? Rows between unbounded preceding. That means you can pick all the rows between unbounded preceding. Unbounded means take all the values. Take all the values. Take all the values, all the preceding values. Now the upper part of the range is this current row. Window dot current row. Simple. Let me just show you once again. We need to tell the rows. It will pick all the unbounded rows, all the preceding unbounded rows. Then the upper part of the range is current row. Just stop at the current row. Simple. Whew. Now let's run this command. Okay, let's see the result. Okay, boom. Now you can see it is showing us the cumulative sum 51, 195. Then it will keep on adding MRP. So this is the function cumulative sum. Oh, if you have understood it, well done. Slow claps. Really, because when I was learning this function, I learned it in SQL first. I watched that part like at least 10 times and I practiced it at least 15 to 20 times. Then I was able to actually crack that. So it happens. If you didn't understand it in one go, do not worry at all, because the person who is like teaching you how to perform it tried it like at least 20 times, then I got it. So do not worry at all. Just practice it like 2 to 3 times. Just rewatch this part 2 to 3 times. You will get it. Just try to understand it. Do not worry at all. Now I want to add one more thing. Do not worry. Do not worry. It is easy. I want to add one more thing, because many of you will be very curious after having that function. Let me show you. When I use this function, current row, this one, you must have seen another function called unbounded following along with this. unbounded preceding and unbounded following. What if we use unbounded following here instead of current row? Just guess. I will tell you, just guess. So you know the concept, right? You know when we write unbounded preceding, it takes all the preceding values. If we write unbounded following, that means we are telling Spark you can pick all the values you want in the following records as well. So what it will do, if you have guessed it, you gonna be beat lots of candidates. So the output will be, it will just give us the total sum of the column in every record. Let's display that as well. Let's do it for you guys. Let's do it. So here now the upper range of this rows between function is window dot unbounded following. Yes, this one. Let me show you. So it will have the total sum of MRP in all the records, no matter what is the value. See, 120 something, I think it's 1.2 million. Yeah, it's 1.2 million. So now you would ask, like, why do we need to perform this function? Like, why do we, oh, let me just rename it first. It's not cum sum, it's like total sum. So I'm coming to your question, don't worry. Let me just rename first. So now you will be asking, like, why do we need to perform this column? Like, why do we need this column? So the thing is, if you want to find some, you can say percentages, margins, where we need to actually have that column in front of our eyes so that we can just easily calculate the percentages, or we can build important KPIs, it is very relevant. So that's it. And now you know how to perform window functions as normal aggregation functions, or you can say vice versa, using aggregation function as window functions. It's up to you. So this was all about window functions. I know it was tricky, and do not feel that you are dumb or like you are not understanding this part. I tried it at least 20 times few years back when I was learning these things. It was really difficult to understand, but with my practice I was able to crack the concept, and I was able to actually visualize those things in front of my eyes. So just rewatch this part and just comment down once you grasp this part. So let's learn another important topic in PySpark. So it's time to discuss user defined functions. Okay, after discussing so many functions, so many functions, now we want to create our own functions. Wow. So these functions that we have discussed so far are not enough for us. No, not at all. Now we want to create our own functions. Wow. So don't worry, it's really important to cover these jokes apart. So we will be covering this area as well. So let me tell you, why do we need user defined functions? In short, we call it as UDF. Again, a fancy term. If you hear this, like someone asks you, hey, do you know UDF? And if you will say, hey, what is UDF? They will see you like, hey, don't you know about UDF? Bro, you could have said like user defined function. So it's just for your understanding. If someone asks you like, do you know UDF? Yeah, user defined functions. So why do we need user defined functions? As I just mentioned, if we want to perform a transformation which cannot be achieved using the functions that we have discussed so far, or it can be achieved but it is really complex when we are using those functions, and we know that we can create a much simple function in Python to achieve the same result, we should and we can use user defined functions. So this is the reason behind we have user defined functions in PySpark. But here is a catch: we should not use user defined function. Reason is very simple. Because of the performance issues. So it is always recommended that you should use the functions available in the PySpark library itself instead of creating your own function. Yes, if we do not have any workaround, then obviously you will be using, but try to avoid it as much as you can. And I know you are really excited to know the reason why we should not use user-defined function. Let me tell you. So do not worry about this part. So this is just for your understanding. So we are not going deeper inside the architectural side of this part because we are covering PySpark. But still, it's my duty to give you all the possible information. So let's suppose we have executor. What is executor? Quick revision for you. Executors are the real machines which perform the execution of the task, which really do the transformations. In that machine, we have, let's say, JVM. Let's say we have JVM. JVM is nothing just Java virtual machine in all the executors. Let me write here executor. Now, by default, we just have JVM, right? But now let's say you have created a user-defined function and you want to use that function instead of any other function. Let's say you do not want to use init function or lower function or upper function. You want to use your own function because of any reason. So when you do that, actually you are writing your code in Python, right? But our executors support JVM. They do not understand Python. So what they need to add in this machine? They need to add Python interpreter. So when we add Python interpreter, first of all, it will use more time to interpret the code first in Python. Then it will create that code to JVM and then it will execute it. Plus, it obviously use resources. So in both the situations, we are losing performance. So that's why it is not recommended, but still we have leverage to use user-defined functions. So just try to avoid it as much as you can. But if you do not want to avoid it or you cannot avoid it, we have user-defined function. Do not worry. Let's see how we can create user-defined functions. Then how we can create that user-defined function into a PySpark user-defined function, and how then we can use that function. Let's see. It's really easy. Don't worry at all. So here, let me first write heading. First thing. User defined functions, UDF. Perfect. So this task is divided into 3 steps. Step number 1, you first need to create step 1 you first need to create a UDF. UDF is nothing but a Python function. You can create any function. Let's create a function. Okay, so what it will do, so for those who are not aware of Python, so this is just the code that we are using to create a function in Python. So first we write def to initiate the function. So def, let me call it as my function. Okay, this is our input, that is x, that will be our column. So now I want to return, let's say, x into x. Simple, right? Let's run this. So now what it will do, it will take one value and it will return the square of it, because as you can see, x into x. So if I provided 5, it will just return me 25. Simple. Now I want to convert it into PySpark UDF. How we can do it? It's very simple. So let me just write step 2 first. So this is step 2. Okay, step 2. And now what we will do, now we need to create a function name. So I will say my UDF. So what we will do, UDF, and then we just need to write this function. This is my function. So what we are trying to do here, let me show you. We are creating a PySpark function, which is my UDF, using UDF command, and then we just need to write our function that we have created in Python. Simple, just run it. Now that function is converted into PySpark function and the name is my UDF. Now I can use this function as the functions available in PySpark. Now it is registered in PySpark. Yes. Now we can use this function as normal functions we were using in PySpark. What do I mean? What do I mean? Let's say I want to return square of item MRP and I want to use this function. Okay, let's do it. df.with column, and column name is my new column. What? Then after this thing, now we will use our function that we created, my UDF, right? Then we will just type the column name item MRP. Simple. Just say display. Let's see. So perfect. Now it has created a column which is returning us the square of the MRPs, and now we have used our own function. So this way you can create as many functions as you want, but don't you dare do it, because the reason is it will not be performant enough to run your notebooks, because it's not recommended. It needs to add Python interpreter every time in the executor, so do not do that. But still, if you are facing any kind of roadblock, you should go with UDF, where you have to use your own user defined functions. So that was the intent behind the user defined functions in PySpark. Now you know user defined functions as well. So if you want to create any other function, you can try, you can just build any function you can, because it is allowed. So this was all about UDF. So after covering so many functions, we have also covered UDF. Now it's time to look at the other side of data, which is data writing. So just be with this video to know how we can write this data in multiple formats. Let's see. So after data reading, after transforming the data using so many functions, it's time to actually write the data. So as we just saw that workflow like this, so let's say we first read the data, then we transform the data. Wait, let me just redraw it. First we read the data, then we transform the data, and now the major thing. Now we need to write this data. So as you know that we can write the data in many formats. Let me show you like what can be the requirement look like. So let's say this was your file that you read maybe in JSON format, CSV format, Parquet format, Delta format, any format. I don't care. Once you read the data, once you entered into the reading zone, you just pulled the data and you created data frames on the top of it. Okay. Then you perform transformations. In the second layer, you just performed all the transformation using so many functions. Now here is the most critical part. Why I am saying this is the most critical part, there's a reason behind it. Because we did everything just to serve our data. This is our serving layer. So this is called serving layer. So we were doing each and everything just to serve our data, maybe to data scientists, data analysts, business analysts, reporting analyst, anyone. So we did each and everything in these steps just to serve our data to this layer. So this layer is really important. There are some things that we should consider while writing the data, because I know you transform the data really well, you read the data really well, but it's your duty to write the data cautiously because it can make a huge impact when you write the data. You have so many modes available while writing the data. You have so many formats available while writing the data. You have so many schema changes while writing data. You need to figure out each and everything. You need to validate them and then you should perform data writing. So we will be covering this topic now because we have seen how we can read data, data transformation. Now the third step, data writing. And don't worry, we will be covering all the data formats, all the latest formats as well. So just be with this video and let's see how we can perform data writing efficiently. Let's jump onto the PySpark notebook. So now it's time to explore data writing. So we are working with Databricks notebook. So obviously temporarily, because this is a community edition, we will be using Databricks default storage, but in real life, in real time scenarios, where do we write the data? Let me tell you. Let's say just a hypothetical situation. You are working with Azure, right? Okay. And where do you write the data in Azure? Yes, you guessed it right. It's ADLS Gen 2, which is also known as data lake. So you are, let's say, writing your data in data lake. This is the data lake. Don't mind my drawing. So this is the data lake that will be used by Databricks to write the data because we need a storage. We need some dedicated storage location so that we can pass in this Databricks notebook and it will take that DF and write that data to the desired location. Okay, let's not only promote Azure, let's talk about AWS as well. So let's say you are using AWS, okay, and where you write your data in AWS? Yes, in S3. So this is your S3 storage location. So in both the scenarios, you need to provide a dedicated location where you need to store your data, where you need to give the output of the data frame so that that data can be picked by the reports, that data can be picked by data scientists, that data can be picked by data analysts. Or if you want to create tables on top of it, you can create. Don't worry, we'll talk about it. Don't worry, don't worry, don't worry. So this was all about the storage. Now we are using community edition, right? We do not have Azure account right now. Where we will be storing that data? In default Databricks storage account. But you can just relate that we are storing our data in the cloud. Obviously we are using Databricks cloud, but that is not enough. That is just for your exploration. In real life, we will be using Azure, AWS to actually store the data. Don't worry, in my other videos, you can explore Azure a lot because it's all about Azure, Azure, Azure. But in this video, it's just about Databricks Community Edition. So let's see how we can write the data. And let's start with the basic one, CSV, how we can write the data in the CSV format. So let's start with CSV. Okay. So let's suppose I have this data frame, which is DF, and I want to save this data in cloud and I want to save this data in CSV format, right? Simple, sorted. Okay, let's do that. And for those who don't know what is CSV, CSV is CSV is comma separated values. Simple. So how we can just do that? df dot write, df dot write. This is the data frame writer API. df dot write. Then we need to specify format, which is CSV. Simple. Okay, this is done. Then we need to say dot save, and then you can just define the location. Yes, simple. But here we do not have any location, so we'll be using Databricks location. So now we will be providing Databricks location to this code. So we already know that it's file store, then it's tables, then we can say CSV, and then we can say data.csv. Simple, 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 simple. Let's run this. Perfect. So it just ran our writing command. So it just wrote the data in CSV format in this location. But one thing is missing. Do you know what's that? Writing modes. We just mentioned that word, writing modes. What are these writing modes? Let me explain you. What are these writing modes? These are really, really important. And being an efficient developer, you should know these writing modes. Let's discuss these writing modes and let's come back to this Databricks notebook after covering those writing modes. Let's see. So let's discuss the writing modes that we have in PySpark, and these modes are really, really important. And I have just provided you the list of modes that we have. Don't worry, we will be covering each and every mode in detail and what does it mean and when we use which mode. So let's start with this. As you can see, the first thing that we have is append. This mode is really handy and this mode is really helpful when you do not want to lose your data. What does it mean? Okay, let's say we have a DF, a data frame, right? Let's create a data frame quickly. Yep. Let's say this is our data frame and this is your folder. This is your storage, or this is your maybe a kind of folder in which you want to save your DF like this, right? This data frame, you want to save it in this folder. Yes. Now we already have a file there. We already have a file there. Let's say this is our file which already exists there. The same file, maybe someone ran the pipeline, someone ran the script, and we have data there in CSV format because we are working with CSV. By the way, these modes are already there in all the formats. It's not just restricted to CSV. So I'm just giving you an example of CSV. Let's say we already have data.csv file there. Now we just ran the append mode. Okay. Now what it will do, it will just run this append statement and it will just send the copy or maybe any data frame, the data frame that we have selected. It will send this data frame here no matter if it has data or not. That means in that folder one file is already there, no worries, it will just add another file and it will say, hey, this is your file. If we have not selected the file name, because obviously if we say data.csv, it will just replace it obviously. So when we are just providing the folder location and it already has the file in it, so what it will do, it will just add another file. It will append the folder. It will just add that file into that location. So in this scenario, you are not losing any data. You are not losing anything because data is already there. Okay, our data is already there. So this is the working behind the append mode, and this was all about append mode. Let's talk about overwrite mode. This is really, really sensitive. Use it carefully. What it will do, let's say this is your data frame. Okay, this is your data frame and this is your folder. Here, let's say we have a file called data.csv, which is already there. Now we have said, hey, just overwrite it. Just use overwrite mode. What it will do, it will take this latest df, this one, and it will just write this file into this folder. But as the name suggests, it will overwrite it. It will delete this one and it will insert your new data.csv file. So in this scenario, you can lose data. Just use this mode cautiously. Okay, so you need to be responsible. If you lose any data, don't come to me if you lose any data. That doesn't mean that you should not use this command. it is very handy when you are using staging tables, when you are building staging layers, because in those layers we need to truncate the data. Once you start working with the data engineering things, you will know like this is very handy and this is really really easy to use in those layers like staging layers. So this was all about overwrite mode. What this command might like, what this mode is doing here, this is error. So what it will do, it is smart. This one is smart. So let's say we have this blue data frame and this folder. Now let's say we have a file here, data.csv, and it will say, hey, okay, run this command and use writing mode as error. So what it will do, it will say, okay, I will run your command. It will run the command and it will just check the folder. It will go there and it will see the folder. Then it will say, hey bro, error, error, error. We already have a file there. Why you are asking me to write the file again in that folder? So this command is very handy when we want to throw an error if the file is already there. So it will not write anything and it will throw an error. Okay. Now, fourth one is ignore. Don't ignore it. Just the name it has ignored. We do not need to ignore it. Lame humor. Okay, lame. So now this is our data frame and this is our folder. What it will do? It will just go to this folder and it will say, hey, one file is there, but I don't care. Ignore it. It will not throw any error. It will just ignore it. It will not write anything. It will not throw any error. It will just ignore it. So this is very handy. When you do not want to overwrite it, when you do not want to throw any error, it will just ignore it. It is very chill. It is chill. So this was all about ignore. So we have covered all the 4 writing modes. We just learned the concept behind the 4 writing modes. Let me quickly recap everything. Append mode will just append the files. It will just add the files. Overwrite mode will just overwrite the data and it will just truncate the folder. Error, it will just throw the error if file is already there. Ignore, it will just ignore if file is already there. File is already there. So this was all about data writing modes. Let's see how we can do it using PySpark library, how we can do it in Databricks notebook. Let's perform all these 4 operations on our CSV file format. Okay, let's see. So now it's time to look at the writing modes, how we can implement it in Databricks notebook. It's really, really easy, but be cautious. But I think you are cautious now because you know the concept behind all the writing modes. Which one you want to try first? Let's try append mode. Okay. So as we just know that we have already written our data in this location, right? And I want to just insert another data frame. I know the data frame is exactly same as it was before. I want to insert it. It's my choice. Okay. How we can do it? I will simply say df dot, let me just create an heading. So it will say writing modes, or let's say append. Okay, simple. So let's say df dot write dot format is CSV. Now I will say mode. What is my mode? It's append. Perfect. Now I will say dot save. Let me just copy the location. Let's run this command. So it will just add another file in that location. Simple. See, it ran without any errors, without any issues. Simple. Yes. Oh, there's another way to write this. Let me show you that as well because I love that. I just use that way. So what we can do, we can just write here dot option, right? And then you can say, hey, path, then comma, this is our path. And then you can say dot save. So this is another way of writing it. I do like this one. I don't know why, but it's up to you. If you want to use this one, you can use this one. Otherwise, you can use that one as well. See? So now it's time to see the overwrite mode. Overwrite mode, okay sir, let me show you. Overwrite. So what it will do, it will just overwrite the folder. It won't care anymore that it has files. This is like, dude, it will just say, hey, get out of my folder, I have come, so just leave the space. So it will just truncate the folder and it will just write this version of data frame. So let's see how we can do that. df.write.format, and then we will say CSV, obviously. Then we will say dot mode. Mode is same, CSV. Hey, mode is not CSV. Mode is overwrite. Then we need to say dot option. Let's say, let me just copy this. Okay. Option path and simple, then dot save. Let me run this. Oh, spelling mistake. Sorry guys. Sorry. Okay. So what it has done, it has overwritten the folder. It just asked all the files, just get out of this folder, and it will just save the latest data frame version. Simple. Now I'm really excited to test error mode, because now we already have a file in that folder and it should throw an error because we are trying to save that data in the location in which we already have a file. Let's test it. Let's test it. Okay, we can say this is error. It's also known as error if exists, and maybe they have just renamed it as error. I have worked with both the statements, so both work fine, don't worry. So error, we will simply copy this code, just paste it, and here we will say error. It should throw an error. Let's see. Oh wow, this is the only error that I love in PySpark. This is the only error. See, so now what this is saying, it is saying, hey bro, you're asking me to write the file. No worries, I can write, but you dumb, this folder is already populated with a file. Why you're asking me to write the file there? So it throws an error there. Simple. Now let's test ignore, right? Ignore command. So in this ignore command, we can say, hey, if file is there, just ignore it. Don't disturb us with this red error. So let me just copy this and just paste it here. Ignore. Perfect. So now I should not see any error. Simple. So this was all about the writing modes. Yes. Now the next step is to look at different file formats that we have other than CSV. We have a very popular data format, that is Parquet. Do you really want to look at this? Let me show you how you can save your data in Parquet format. And before that, let me tell you how Parquet format improves the query performance. Like, why do we prefer Parquet format? What are like column based file formats? Let me give you an overview, because this is really important, really an important concept. We know we can just simply change the format here from CSV to Parquet and it's done. Bro, you need to understand why we are using Parquet format, why it is the first choice in today's era if we want to save any data. So let's see how things work behind the scenes for Parquet format. So now it's time to understand the Parquet file format, which is also called as columnar file format. So columnar file formats include such as Parquet, Delta Lake, and maybe ORC. So these are some of the examples of columnar file formats. Why do we use these file formats, and why these file formats are very popular, and why these file formats are our first choice whenever we work with big data such as, let's say, have millions or billions of records, and this is the first choice in Databricks as well, like using Spark. Why? For that, you first need to understand how data gets written in row format and in column format. So let me give you an overview for row format first. So obviously whatever data we have will be written in the disk, right? Either it's like cloud or anything, it will be written in disk, right? So let's say we have the data in row based file format, which can be maybe Avro or any kind of file, row based file format. So let's say this data will get written in pieces like this. First of all, it will pick this record. So as the name suggests, row based file format, so it will pick the data row by row. First of all, it writes 1 gor d01. Okay, this is our first block, right? Then it will write this record, this row, because data gets written in continuous manner in the disk. So then it will have this record. Let's say with green, we can say 2 kit and then d02. So similarly, all these records will get written in the disk in row based file formats. These are really handy when we need to write the data. Yes, not write like big data writing, no. When we are writing data, let's say using OLTP databases, which are transactional databases, where we need to just apply CRUD operations frequently. Let's say if we want to just change the name, like this name, then it's very easy to find this record. It's very easy. So this way we can use this file format when we are dealing with OLTP databases or transactional databases. These are really handy. But in case of big data, when we are querying so many records, we cannot use this file format. No, then we have to write our data in the columnar based file formats, and let me show you how it stores that data. So if we are writing the same data frame, this one, in columnar file format, how it will do, a columnar file format. Okay, simple. So now in columnar file format, it picks the whole column. It picks the whole column. Simple. It will pick this first, 1 2 3 4 5. Simple. It will create a block of this. Then it will store another column, like let's say this one. Then it will create another block with this. And it will say Gore, Kit, Sam, Tim, all these names. So it will pick the whole column in one go. Then it will store the second column. So what is the advantage we get when we store this kind of file format? Because whenever we will be querying the data, we can say, hey, we need select this column name from our table. So this way it will just fetch the necessary columns. It will not look for all the columns. Whereas in case of row based file formats, it will be looking for all the columns. And in big data, we do use queries with certain columns instead of having all the columns in one go. So that's why it is a better approach whenever you want to store the data which is relevantly big in size, relatively big in size, and which is really causing some performance issues. So in that scenario, you should use columnar based file format. And today's world, we just use columnar based file format whenever we are dealing with big data and whenever we are using Spark. Yes, we do use CSV file format and all, but I'm just telling you for the storing the bigger data sizes. So in that scenario, you will be using columnar file formats frequently. So that is the story behind Parquet file format, and that is the working behind the Parquet file format. Why do we use Parquet file format? So this was the answer, and I think this will help you a lot when you will be making decisions to actually store the data in columnar file formats. So I think this is it for Parquet file format, and let's see how we can store the data in Parquet file format in PySpark. It is very easy. So now it's time to actually look at the Parquet file format in our data writing. It's very simple, very simple. Let's say you want to override the folder with the Parquet format, and let's see how we can do it. So you can simply pick this code, just copy this code, and let's say, let me just put the heading MD Parquet. Simple. So what it will do, let me show you. This is our DF, okay, and this is our folder, and this folder has .csv file. It will go and say, hey, just truncate the folder for me, and it will just remove that file or any files being stored in that folder, and then it will write this data frame in Parquet format in that folder. So let's paste that code and let's say Parquet. Simple. Just run this code and it should run successfully. Yeah, perfect. So now we have written the data in Parquet format. There is one more very popular data file format which is really new. Yes, you guessed it right. That is Delta Lake, Delta format. What is Delta Lake, Delta format? Actually, Delta format is built on top of Parquet format. Okay, then what's the difference? Difference is, let me show you. When we have, let's say, this file, this is our Parquet file, right? That we have just written. In this, we have header, and in Parquet file format, header gets stored in the footer. Here, let's say we have header means like metadata. So in easy words, easy language, we call it as header. Metadata. Metadata gets stored at the footer of the file. In case of Parquet, let me type it. Parquet. Simple. Okay. In case of Delta Lake, or you can say Delta file format. Let's say this is my Delta file format. In Delta file format, metadata will not be stored in the files. No. Then where it will be stored? We need metadata to execute files. Okay, let me tell you. It will use a transaction log, which is also known as delta log. So this will keep all the information regarding metadata, regarding updates, regarding everything. So this is our delta lake, which contains Parquet. If you just check the file formats, it will be written as .parquet, but along with it we will have this delta lake, delta log. We will be having this transaction log, which will actually hold that information, metadata, everything within that delta log. So this is the difference between Parquet file format and delta file format. Delta file format is the future. Delta file format is the, you can say, backbone of lakehouse concept. Just try to explore Delta Lake, Delta file format as much as you can. It is very easy, and you can expect lots of usage of Delta Lake, Delta file format in my channel. So just check that out. I will just mention all the relevant links in the description, so don't worry at all. In future, you can expect lots of videos based on Delta Lake, Azure, Databricks, everything. Crazy content on your way, bro. Just wait. So this was the difference between Delta Lake, Delta file format / Parquet. So now I think you are aware of this thing. One more thing that we need to discuss before completing data writing part. If we want to create table, yes, if we do not want to write the data, if we want to create table, how we can do that? Let me show you. very simple. Let me first write table. So let's say we want to create table on top of it, right? And here the only difference we need to make, first of all, we will be removing location because this will be a managed table. So here, instead of writing save, we will say save as table. Simple. Now we can obviously give name to our table. Let's say I call it as my table. Run this command. Run this command. So now what it has done, it has created a table for us. Yes, table. You can now use SQL. Don't worry, we are going to discuss Spark SQL as well. Not very much in detail because everything is similar to PySpark library. It's just like we can use SQL statements on top of our data. But I want to discuss that. That is important for you. So now our next step is discussing Spark SQL, Spark SQL. Let's see what is it and how we can actually perform SQL statements, SQL queries on top of our data frames in PySpark. Let's see. Wait. Before jumping on to Spark SQL, we need to cover one more important topic because I cannot leave this topic. This is a small topic, but this is really, really important when you are working as a data engineer, when you are preparing for a transition. For every perspective, from every perspective, it is really important. So just try to cover this small topic before jumping onto the Spark SQL because it will definitely help you a lot and it will help you to excel as a PySpark developer because this is a critical topic. And let me tell you why it is critical, and let me actually explain this topic. You will definitely get it why it is so much critical. So the thing is, we have a topic called managed versus external tables. I can guarantee that you must have heard these terms because these are really popular nowadays. After the introduction of lakehouse concept, this is really, really popular. What does it mean when we say managed table and external table? Okay, and we just created one managed table if you remember, because I just mentioned that we are creating managed table, not external table. Like, what is the difference? Let me tell you. So let's take an example in which let's say we have this data frame. Okay, we have this data frame and we want to create a table on top of it. Okay, we can create a table on top of it. Actually, when we create a table on top of anything, we are writing data somewhere. That's common sense. It is not storing the data in the air, it is storing data somewhere. So when we say, hey, just create a table. Okay, this is our table stored in, let's say, database. Okay, so actually the table that is seen in this database, we are actually writing this data to some location. Yes. So when we created this table just few minutes back, so actually we just created table on top of this data frame, right? And we could see the table, but data was stored to some location. Data was stored to Databricks default storage location. That's called managed location. That's called managed table. So when we talk about managed, so in that scenario, the data that is being used to create the table is managed by the Databricks. Managed by Databricks. Let me type it here with maybe red. Managed by Databricks. This data is managed by Databricks. we are just responsible for this table. So when we say, hey, delete this table, hey, drop this table, it will delete the data as well, because this data is not in our control. This one, see, this data is not in our control. When we say delete this table, it will automatically delete this data as well, because it will think, hey, they do not require this data. So this is called manage table. Now what is external table? And I love external tables because we store that data. Let me tell you. Okay, in case of external tables, what we will do, we will first of all have a data frame, and we will, let's say, have this data frame, and we want to create the table on top of it. We want to create the table on top of it. Similarly, same thing. But this time, the data, this data will be stored in our own location. Yes, I will give my own location because I am owning this data. So whenever I will be performing any delete operation, let's say, or any kind of update operation, it will not delete this data. Let's say I said like drop this table, it will not drop the data at all. It will just drop the schema. It will just drop the schema that is stored in the database, but this data will remain the same. So that is the external table. That is the external table. Yes, and this data is managed by us. This is the difference between managed table and an external table, and this is really an important concept. And you guessed it right. Whenever we want to save our data, whenever we cannot risk with our data, we should always go with external tables. And how we can create external tables? It is very simple. You just need to mention the location as well whenever you are creating the table. That's it. It is very simple. So obviously when you work with cloud, Azure, AWS, you give that location and it will actually store that data into that location, and that is managed by you. That is external table. But when we are practicing, we can just create managed table because that data is not critical to us. If we say drop, it will just drop the data as well. We do not care. That is the difference. You should know. And now it's time to look at Spark SQL. Let's go. So now it's time to discuss Spark SQL. All the SQL lovers gonna love this session. This is a very short and very brief session. Don't worry at all. We are not going into deep because this is exactly same as SQL. If you are familiar with MySQL, if you are familiar with PostgreSQL or any kind of SQL, this is like very easy for you because this is exactly same as this one. Now, before jumping to Spark SQL directly, before running SQL statements, we need to discuss one important thing. We know that we are working with data frames, right? And let's say this is our data frame. Let me display it. Df.display. Yep. Just run this command. So this is our data frame. We told one thing in the beginning, that you can perform all the functions that we are performing in PySpark. You can perform all those functions using SQL. What do I mean? If I want to find some operation, if I want to do any kind of aggregation, if I want to perform, or you can say use window functions, I know SQL. That means I can use SQL statement on top of my data frame. But bro, this is data frame. This is Python API of Spark. How we can use SQL? For that, there are some options available that you can use. One good news for SQL lovers. There is no performance difference when you use PySpark API or Python API of Spark and Spark SQL. If you are familiar with SQL, if you want to just use SQL only, like people do not use just SQL, but if you want to use SQL, use it freely. There is zero performance difference between PySpark API and SparkSQL. So it is up to you which one you want to use. First of all, obviously, if we want to read data, we will be reading that data in the form of data frame. Now, our next step should be converting that data frame into an object on which we can run our SQL queries, right? And it's very easy. Let me show you how you can do it. So first of all, we just queried our data frame. So now if I want to use any SQL command, I want to convert this data frame into a temporary view. Let me just write it here. Temporary view. What this view will do, okay, what this view will do, it will create a temporary view in our cluster, and then we can just query this view as we query view in SQL. Simple. Then you will be asking, hey, every time we will be creating view, so there will be so many views. So what? You don't need to worry at all, because all these views will be eliminated once the session ends. Yes, you don't need to worry. It will not create permanent views in your memory. No, these are temporary views. This will be used when you are just using the notebook, when the session is running. Once the session ends, boom, views are eliminated, views are gone, there are no views. So I know now you are very excited to run the code. Let me show you how you can do it. So there is a function called, let me write it here for you all. There's a function called create temp view. So we will be using this function to create temporary view from our data frame. Let's see how we can do it. And once it is created, you are free to use SQL. Just run your all the SQL commands on the top of this view. How we can do it? Let me show you. So first of all, let's create a new markdown. For my SQL lovers, we will say Spark SQL. Simple. Then I will say creating data frame. When I started learning PySpark, I was really happy that we have SQL in PySpark. So whenever I used to face any issues, I used to say these things to myself that, okay, if I am unable to do these things in PySpark, I can do it in SQL. This way you can boost your confidence while working with PySpark, right? But trust me, once you know PySpark API, you will not be using SQL much, but still, let's say you are using window functions. And I know SQL provides much more, you can say, structured way to use those things. If you are confident enough to use window functions in SQL, then you can replace PySpark API with SQL just for performing window functions. That's it. So it's up to you. So you should know both the areas. So first of all, just create data frame, create temp view. Simple. So we will write df dot create temp view. As you can see, here we have create temp view. Then we need to name this view. Let's say, let me call it as my view. Simple. And now you can run your SQL statements on top of it. Yes. Do you want to test it? How we can do it? There are two ways. Simply here first, let me just zoom it. Here we have Python box. So you just need to change it to SQL. See, so it will just mention a magic command %SQL. Now you are free to use SQL. How you can do it? Let me show you, bro. So for example, don't feel offended if I say bro. Bro means boys and girls both. So bro is not just for boys. So select asterisk from my view. Simple. Simple. Let me run it. Magic, magic, magic. No, it's not magic. It's the power of Spark that we can use SQL. See, Now this time we just ran the select statement on top of our view and we were able to see the data frame exactly that we were seeing using data frame API. See, do you want me to perform some transformation? See, okay, let me write where clause as well. Where let's say item fat content equals to LF. Okay, this will return this as well. See, it returned all the values are LF. It is really easy to use SQL in this because it is exactly same. So now I know you have one question. I also had this question. So the question you have right now is like, okay, once we converted our data frame into view, okay, we perform transformation, okay. Now we want to write this data. How we can write this data? Because okay, we can see the result in Databricks notebook, but we also want to write this data. So you can just convert this result into data frame. How? Let me show you. So you have the statement, okay. So there is a function, or you can say a kind of API that you can use. So you can say df, let's say new, okay, or let's say df SQL. Now you just said that you want to save this result into a df so that you can perform writing part, right? Like, or maybe you want to join this data frame, or as I just mentioned, if you just want to use SQL for a small task just to replace window functions, and you after performing that functions you want to write back or convert back it to data frame, we can do it. How? We can use something called spark.sql. Yes, simple. Let me just show you. Spark.sql function. Just write this, then write your query. Let me just copy that query for you all. Just write this query. Okay. Use single quotes, obviously, or just double quotes because we have single quote content already there. So just use double quotes, and then what it will do, I just ran this box. Now it just converted my SQL statement result into a data frame. Do you want to see it? Let me show you. df sql dot display. Simple. So now you saw how easily you can just use both the areas, Python, SQL, and you can integrate both like this. It was so easy. And I know now you are feeling much more confident while using PySpark because you know, whenever you feel stuck, you can use SQL like this. And this was my positive area as well when I started learning PySpark few years back. So this is for you as well. Like you can also feel positive and you can also start and exploring more and more inside this area. So now it's time to wrap up this long video format. I have put my all the knowledge, all the efforts to make this critical part easy, accessible to all of you. This video, I think it's like more than 6 hours of content, and I wanted to create this video so that you do not need to go anywhere else. You just need to start this video, one-stop solution to all your PySpark questions, all your interview questions, all your real-time scenarios, everything from scratch so that you can learn in a better way. Because I still remember when I was learning PySpark, I had to refer so many resources and it was such a chaos. But I wanted to make things easy for you. This is my very first video on this channel, but you can expect so much of related content, data engineering content, cloud data engineering, Azure data engineering, Databricks, projects, tutorials, master classes, everything. because this channel is just for my community. So stay tuned, just hit that subscribe button. It will definitely motivate me a lot and it will help me to grow. And thank you so much. See you next week with an amazing project. Love you, my data fam. Love you from heart.